Hey guys, welcome to day 6 of this build a game in Rust series. And from the part 1 of the series, we've been talking about working with Rust and building with Rust, and the Bevy engine, which is a game engine that we can use to build games or any other thing aside from even games. You can use to build like web games, desktop games. Also, you can use to build things like servers and all of other things that are like crucial and need very um that are more low level, right? You can use it to build any of those things. So anything else to it, those kind of aspect of low level implementations or generally anything that requires an engine, probably something that requires you to write a very efficient server or a P2P messaging system, something that requires something very crucial and memory efficient. And then you can use Bevy for implementing all of those things. And then it has a very good UI engine that you can use to implement any visual you want to, or you can think of, basically 2Ds, 3Ds, animations. Think of it. Of course, it's not a very production ready framework or an engine, right? But it is very much useful for whatever use cases which you might be thinking of using it for a beginner or an intermediate user. So yesterday, which was the part 5, we talked about implementing a game. So what we did was to combine two different applications that we wrote. We wrote a game menu in part 4 of this series. We wrote a game menu in part 4. So and we also checked out how to despawn, right? How to remove an entity the from the view or from the world itself that we've already defined. So we used that implementation and combined it with the game menu, and we're able to create something beautiful in the sense that we created something that allows us to be able to create a user, create a game, right? That using the menu, you can actually trigger the game to start up. And we were able to do that successfully yesterday. And then we did something simple also. We started using AI to speed up our workflow so that we don't need to write every single thing that we'll likely use for the implementation. So those were the things we did yesterday, and then we started with that, and we were able to implement a lot of things. Also along the way, we learned how we could use AI, how we can use some free AI models. I also about those things, and then I mentioned all other um, kind of crucial to how we implement all of those things. So today we are going to proceed from that implementation of yesterday, and it's basically going to be a continuation from where we stopped yesterday. And remember, from yesterday we talked about what we are going to do today, and I showed you guys some of those things also. I mentioned we're going to be working with some implementations like some collision systems, collision detection. We're going to work with especially with collision detection today, and add some other features to our existing game of yesterday, which we can do at any point in time. So those were the major things we talked about yesterday. And um, so in order not to waste time, let's jump right into it because we have a lot to do today and to cover today. So this was the game we wrote yesterday. Let me just rerun this so that we let's see. So I will run this so we can see what is being implemented. So yes, also yesterday we had a lot of issues with my screen being with sharing my screen yesterday. It was just misbehaving, getting cut off in the middle of the stream, and it was terrible. But I was able to resolve that. It was just basically due to space issues, and I had to do a bit of tweaking and removing today, just to make sure that I have enough space so that that will not repeat itself. So that's basically our work today. So yesterday, I'll click on this. So this was what we did yesterday. If I we render this menu such that we have this menu. Initially, this menu do not do anything. So if you click it initially, it will just take you to a blank screen and tell you that, oh, this is this and this is this, and then takes you back to the menu after 5 seconds. So, but we thought of it, how can we extend this, right? Because we do not want to re-implement what already exists. So we thought of it that okay, we can combine two games together such that we do new game, and whenever we can play this game. This is also a fun game that you can play, and it's quite relaxing also. So it's a game idea. And what we do is it has a countdown. So let's see how long we can do this or clear all the mines. Now, this is not an easy thing to do, right? You don't expect to do it within a minute. Let's say we give ourselves a minute to implement all of those things. It's probably going to take a lot of time to complete this in 1 minute, definitely. But we could try and see whatever we get out of it. So this was what we did yesterday. And then continuing all of this, we just combined two existing implementations and made it into an actual gameplay with other functionalities like the timer, the ability to pause. So if I do this, the game is paused currently. So I can't even click anything here. You can see my mouse. It doesn't work anymore until I resume. And if I click this now, it works. If I pause again and I click this, it doesn't work. If I resume, it works. So basically, that was what we did yesterday. And after the countdown, we just did it in such a way that once the countdown elapses, it automatically takes you back to the menu. Just watch this now. It's already on 3 seconds, two, one, and then takes you to the menu immediately. That means the game ended there. Of course, this is not the way an actual game will feel like, but this just give you an overview of how we can implement these things and the power that Bevy gives to us. So because of the plugin functionality or the plugin paradigm of Bevy, we're able to implement this kind of functionalities by plugging into existing implementation or even taking an existing implementation, rewriting it, refactoring it if it suits our use case, and we can modify what we want, what we don't want, remove certain things, add other things to it, and plug it into Bevy as a plugin, and then we can basically make use of it. And because that was what we did, right? That was what we did yesterday. We took the existing. This is the observer. This is the game that we rendered. When we click on the new game, it was its own existing game, completely defined. So what we did was to remove the main function because we didn't need it anymore, of course. And then we took does just the main. We removed the main because we wanted to reference from the file. Because if you look at it now, we are picking some things also from. Let me look for example. You can see from there something like this. Now we are referencing observer, right, itself from the crate, and then we are picking observer and mine. So if you check mine is coming from here. So it's very much very possible for us to pick an existing example, much more like, let's say you want to render this. Let's go to the game section, for instance, and say I want to render maybe this breakout, like we said yesterday. All I need to do is just get the breakout code, right? There's a lot of code, like I showed you guys yesterday, but it's not that much, right? Because it's just basically bounding and some other bounding features, and take that existing code, modify it in such a way that it doesn't render this application on its own anymore, like this, like what we have here. So what we'll do is just the same way we did yesterday, remove this main application, convert this whole thing to a plugin, and then add it directly to our game so that we can have other features here, for instance, that says um, exploding game, then Tetris. We can have different various sections of our games implemented, right? And what we did yesterday was to use AI to make it faster for us to make all these things, because now we understand that we can read the code, we can know if there are issues, if there are errors, and we can actually fix those errors. And we did a lot of those things yesterday. I showed you where the mistakes were when the AI implemented it. But one of the things you cannot do without nowadays is using AI for your workflow. You have to use AI. Like, it's a necessity. It helps you to do a lot of things. Aside from you deciding whether it hallucinates or not, you cannot deny the fact that you are more productive if you know how to use the AI. So going forward, they are going to be using that, because we are not teaching you just how to write the code. We are teaching you how to use it in a very production ready setup in this case. So even if not production ready, even if as a beginner or what, this isn't the new skill to learn using AI. So whatever example I do nowadays, prior to the way I always teach people that you need to understand everything to start, like as building blocks. Now I always advise people to start with also, once you understand the basics, right? You can read the code, you can interpret it, you can understand if there's an error, even if you don't have the full knowledge of how to resolve the errors, then you can use AI to help you. Let it be an extra and for you, let it be an extension of the knowledge you do not have. But when you see the implementation, you can say, no, this is wrong. And we did a lot of that yesterday. There were a lot of things he added. I was like, no, this is wrong. And we removed it. We canceled a lot of things. We added some things ourselves, but we allowed it to do most of the work because we gave it the instructions that were proper for the execution. So there are other things we can add to this. We can add more functionalities. We can, even to the game itself, we can add the pause, we can add the play, we can add other things, scoreboard, and all of this logic. It's just our choice. But we don't need all of those things for now. So what we want to do today is basically about the collision. I want us to talk about collision. So far, we've not spoken about collision since the beginning of the series. So from say part one, part two, part three, part four, five, and now part six. We want to talk about collision today and understand how they work. So in this case now, if you look at this game, this is a simple game that we are familiar with, right? We play this a lot, and we can see that I can move this item. Now, without even telling you how this is done, you basically know that this is just a transformation, right? A transformation was applied to this mesh. Let me call this a mesh that was defined as a rectangle, right? It's something we can literally create ourselves without the complexity. We can create the basic, create this rectangle, position it, maybe like define the positioning, right? Maybe using absolute positioning, the bottom should be like 20, so it doesn't go to the end of the screen like this. You can see there's space before here. And then we define that. But that means that all we need to do to define this bottom, or let me say the solution that we see here, there's already an existing implementation. We don't need to write a custom thing to implement this solution. There's just a bounding. There's something called bounding that we'll use. Now it's common in almost every game engine that you see out there. They already implemented for you, and that's what allows you to be able to eat something and it leaves. So what this is basically doing is that when you eat this, right, two things that we've learned so far, we understand that this down here, that is here, that we move like this, has to do with transformation, right? Just transformation of translation x and y. Let me say basically in the x-axis, this is just translating the x-axis so that when I press my arrow keys, I can move it in the opposite, in the negative x-axis or the positive x-axis, right? We already understand this from part two, part three of this series. Now, the next thing we needed to understand was, you remember, notice that immediately the ball hits any of those items at the top here, they vanish. That means they are removed or despawned immediately. So that is basically also that is one of the things we talked about in part four of the series. We spoke about despawning, and also yesterday we had to use that functionality also, whereby we're able to despawn an existing implementation. So we did all of those things, and then we saw it in action, right? So the idea now is to see how this collision works, right? Not just the despawning ability. Yeah, so you choose just the collision also in line with every other thing we've learned. Right? Then we see how everything comes together. So far, everything we've learned now is now applicable in this situation, right? Because if you think of any game that you can actually relate to, you know that it has to do with interactions. So we've done how to remove things from the world that we create, how to add certain things to the world, how to switch between screens. Now, what we are trying to learn about is how do we interact with the world. Now, aside from using the camera to just view stuff, aside from that, how do we interact in terms of making objects, two objects interact with each other, or two entities in this case interact with each other? How do you define that? So that's what we are looking at now. So let's go into this just without wasting time. What's first thing I'm going to do is, as usual, I'm going to copy the code, then we can tweak it and see stuff that happens because we're not trying to write it from scratch. We're just trying to make it work for our use case, right? We're trying to learn from it. So I'm going to go back here and now copy this entire code. It's a lot of code, right? But it's something we can read. Literally, if you follow this series from part one to part six now, this is something you can extremely easily read for yourself without issues. You understand what is happening here. The first thing we have here is we have a module called stepping. Where is that defined? Are we missing something? So first thing for we already noticed is an error because we don't have stepping anywhere. Where is stepping coming from? But then let's see if we can resolve that. Not stepping. Okay, so if you go to probably the all right, let's leave that for now. Let's look at the other things that we are sure of. These are the constants we defined, right? This is the paddle size. The paddle size, this is the paddle. This here that I can move left and right is the paddle. We call it the paddle. This kind of games, they are called paddle, right? You can see I can move it, I can move it, and it has this smooth flow. And I think we talked about smooth flow yesterday too. Before the end of the part five series, we spoke about smooth flow and how to implement it. In this example, I showed you guys an example of how smooth flow works, which was okay. I think it was at the animation section. Not really. We talked about smooth flow yesterday. I can remember that very well, and I showed an example of two objects literally following each other, and I told you how to implement that smoothness. It's just by adding one line of code or one adding a function or chaining a function to an existing transformation, and that will just make it smooth flow. I'm sure we'll find it. I can't really. Okay, maybe not all of them are loaded, but yeah, it should be here somewhere. No, it's not in 3D rendering. It's down there a bit. Oh yeah, it was in assets. I think it was in assets. No, it was not in assets. It was still in the examples. So we talked about assets yesterday. In part 5 of the series, we spoke about assets and how to implement some of those things. It was not there. I believe it's still in examples. Hmm. Let's assume most of them are not loaded yet. But yeah. Okay. I will talk about this eventually. Yes, this is a smooth follow. Yes, I knew it was not there. It was in math. So yeah, let me check this out. It should be open by now. All right, so this is what I wanted to show you guys. This smooth nudge, basically, is what causes that smooth movement. But that's not the only thing, but that's what makes it move. So let's just load first, so we'll see what I'm trying to show exactly. Okay, so why this is working for the breakout, so let's talk about some of the things we understand here. So we can see the paddle size is basically a vector, a 2D vector, a two-dimensional vector, right, of x and y. So the gap between the paddle and the floor is defined as 60.0 as a floating point integer. The paddle speed also has a floating point integer, how close the paddle gets to the wall. Then the paddle padding also, which is basically, check this. If I check this now, let me show you guys. You see that it doesn't get to the end of this. So that means there's a padding between the paddle and the wall, right? So before this, you realize we have this math bounding stuff, which is A, B, B to D. And then we have the bounding circle, the bounding volume, and intersect volume because we're intersecting with the word now, we're interacting with it. So it's basically a way of doing this. When we talk about intersection, it's basically you having something like this. So let's say I have a circle in this case, and then let me draw it as a perfect circle. A more, yeah, okay. I cannot draw a perfect circle with this. All right, let me just draw a circle, right? Let's assume this is perfect. And then I duplicate this. Let's say I give this a green color. Intersection of these two circles is the ability to interact like this. You can see there's this space in between them. Now, this space in between both of them, right, that you can have in this case, if you subtract this, or let me say, this space that you see here in between this circle here is our intersection. So we need the intersection to be able to determine when two objects interact with each other. That's why we have the bounding. The bounding is just the bound of a particular object. In this case now, the bounding of this, let me define this. The bounding of this object is basically this, right? This circle is bound to this square. Let me say this is a rectangle, square rectangle in this case. So let me change this color to maybe this beige or white or black. No, let me use the pink, right? Two contrasting colors so you can see it. So this is the bounding of this circle. It's usually bounded to this space and confined to this space. Just the same way, this is also bound by this other circle in this case now. So we can see these two, right? And that means that there's a bounding circle. Okay, fine. In this case, let's ignore the circle and the volume. Let's just understand that that is bounding. And then the intersection we've also explained. So how do we determine when two objects intersect? So in this case, if this intersects with this, we can determine it by knowing if the bound of this particular one is close to the bound of this or has got into the position of this one. So we need we need positioning, we need bounding, we need positioning and bounding to be able to determine if two objects have intersected with each other. So the intersect volume already knows how to handle all of those things. Basically, this is like the simple math behind it, and that's why it's coming from this math module because it's just all calculations. at the end of the day. So I hope that makes a lot of sense, right? So next thing we should, or we are we need to understand is okay, already know how to read this. This is just the basic Rust constant variable declaration. So we want to set the Z volume of the ball to 1. So it renders on top of in case of overlapping sprites. So the idea is you are setting the Z index, or let me say the Z value. In this case, the Z index is, you remember this diagram we drew here, which is our X and Y. You know that Z is always at the front. We have X and Y at the back here. Your Z is always on top of them, not really on top of them. The reason why we call it Z index is because we are looking at it as the height, right? Not the width and the length. The Z in this case is the height. So we always assume the height is higher than the other two positions. That's basically how it is. So that's the Z value. So now the ball starting position, where does it start from? It starts from minus 50, 1, and Z is 1. So you see how we define it. So in this case, we are not using vector 2, which is a two-dimensional vector. We are using a three-dimensional vector for the ball starting position. Why? Because this is basically a circle, right? And then we want to give it the height so that it is positioned above every other object that is defined. So that way it is above all the other objects, even though it interacts with them by, everything I just explained, I just by bound. Yeah. So that's already is able to be implemented. The next thing is the ball diameter, which is 30. In this case, we already know the radius is going to be 15. That means the diameter is 30. Then the ball speed is 400 already. So you already understand this. Then the initial ball direction, where does it start? How does it move initially when it is rendered? Where does it move to? Well, does it move up? Does it move down? Now, you see that in a game, all you need to put all of this into consideration. It's just like you saying now, I want to um you are making a building, right? You want to create a garage where cars can park in. You need to define and also take into consideration. We might not really think of this all the time because it's like second nature to us. But these are things we do not take note of. If you are building a garage, we want to consider, does the car come in backward or forward? And then if the car goes out, does it go out directly into the street, or it needs to go first of all into the um inside any part of the building before coming out of the gate, then entering the street. Now, all of those things are things you need to describe, right? In this case, too, you're also describing the same for the game. When the game starts, the ball is going to move at what speed? It's going to be the dimension. We define all of those things. That's the shape of the ball. And then we need to also define the initial direction. Does it stay in the middle? Does it move? Where does it move to? Those are questions we need to ask and answer. So this is why we don't really need to like reinvent the way writing all of these things, right? Because they are going to be repetitive. So the wall thickness now, which is 10, as you can see from the wall, let's check the breakout again. You can see this gray color. This is the wall thickness. So that's that. And then we can have we see the left wall here, which is F32, that's minus 450. So basically what we see here is just the left wall is this gray color thing. And we remember the width is what? 10, 10.0 floating point diameter, right? A floating point value. So we have the right wall also has 450. So the dimension between them is, so the space between them is like 450 pixels. Not pixels directly. 450 is what the distance between them is, because this is minus. So let's say the middle here is 0, it's negative 450, positive 450. So let's say in terms of like width, it's 450. So in this case, we have the bottom wall also 300, 300. That means it's not a perfect square, it's a rectangle. The dimension already makes us understand that. Then the brick size also is important. The brick size is what? Those are the bricks that are maybe despawned or broken, or let me say removed from the view when the ball hits them. So we define the brick also. Now these are the brick dimensions. The first thing we do is the brick size is this. The gap between the paddle and the bricks is 270. Why? Because this is the bricks. Okay, let me refresh this so we can see. The brick are going to be at the top there, right? Then this is, you can see the distance between them is 270. You can see distance between this and this is 270. That's what this 270 is. Then the gap between the bricks, you can see there are spaces between the bricks also, which is 250. You know what? We are going to show all of these things, but I'm just trying to explain. The gap between the bricks and ceiling is 20. That means between this and this is 20. So we already have all the dimensions we need. Gap between the bricks and sides is 20. Between the sides too. So scoreboard font size, that's this score you see here, score of 11, 12. It keeps getting updated whenever you hit any of the bricks. So we have that as 33 font size. The text padding is 5 pixels in value. Then we define the colors. Then after that, we talk about the stepping plugin. But currently, we don't have the stepping because it's imported as a module. It does not exist in our code because when you see module, that it simply means It's coming from another code. So I assume it's coming from a particular code in the repo. So what we are going to do is to be sure it's coming from somewhere else. We are going to look for stepping. Yeah, as you can see here, there's a stepping in breakout. There's a stepping. So we can pick the stepping. And you can see these examples here all look like the examples here look like alien cake addict. Let me show you where this is coming from. So the examples here for games as 1, 2, 3, 4, 5. But if you check the example here, you can see that there are 1, 2, 3, 4, 5, 6, 7. So that means there are two other examples missing from the actual game view. So we have alien cake addict, breakout, contributors, all defined in the example. Alien cake addict, breakout, contributors. Then game menu and loading screen are also defined, but we don't have stepping and dex toys there. So those are the things that are missing. So we need to now add the stepping for ourselves. So we already have stepping open here. So that means I can open this. So stepping is already implemented. As you can see, today also making use of two different applications and then adding it together. So in this case, this is stepping. I'm going to copy stepping and add it to our own module also, right? Because they are making use of it. So I'm going to create a new file called stepping and add it to the module. I'm going to be adding it to, I'm not going to be adding it to the main, right? Because by me saying add it to module is already adding it here. So I'm going to be adding it to breakout because breakout needs that. So I'm calling it stepping, right? And stepping now have this. It's not a, oh, I shouldn't define this as a step. I shouldn't define this as an actual. So let me show you what I mean here. This is a module, right? You can see this module declaration missing in personal editing features and all of those things. Attach file to main.rs. I do not want to do that. I want to attach it to the breakout, right? So originally it should be for main.rs, but we don't want to do that, and that's why we have it this way. So that's why you see that in breakout here, we do not have that, but we add more stepping, generally defined. So if I go back to stepping here, I don't want to add it to it because it's keep telling me to add this here, so it can be used, but we don't want that. Or two ways we can do it in order to prevent this issue is we can remove this from here, and then we can use this stepping here by importing it here. Use create stepping. That means it's going to get it from there. So we can do that. And also back to this place, we can also remove this because we don't want it to appear there. So back here, we can use this, but then it's still going to complain because it does not exist. So there are many ways we can do it in this case. We can add the module directly and say that we want stepping, but it's not there directly. So what we can do is we can create a module. We can create it inside the directory, just like we see here, right? If you check here, we can see that we have some of those things. We can create everything inside the module and call it just. So I already have some of the modules here that we used prior to now, and I created something I was testing the other time, and that's why you have this as a module. So what we can do is we can add this to a module as suggested, or we can create a stepping slash mod rs or just a module directly and cancel it like this. So we move stepping directly into this place. Let's see if it exists. Yeah, it already does. So we'll delete this or we'll replace this with this. Here, overwrite it. So if we overwrite this now, this should literally stop giving us the errors, and we should be able to use this from here on the module stepping. So we literally have it here, but then I think this editor has misbehaved again. All I can do is I can restart it. Let me just do that. We had that issue yesterday too. So currently we no longer have any errors, right? After making the fix. And going back here, we'll see that we still have one more error here that we need to resolve from the stepping, which we have this Bevy ECS thing, which is weird. on declare creator module Bevy ECS. So I'm assuming there's another crate being used that we do not have currently. And it's not being imported also anywhere. And that will not actually make it work as it's supposed to. After all, we've already done what we have to do to make it work. This is build UI. This function is used, if I'm not mistaken, here. Okay, I was thinking it's using the breakout. Does the breakout use the stepping plugin? Yeah, it does. Okay, so there's literally an error here that we need to fix then. Okay, so let's go back to stepping to see what we can do to resolve this. So Bevy ECS in 10. Why do we have that? Can't we just use ECS? Why do we have to use Bevy ECS? I think ECS is imported, right? We already have it, so why cause that error issue at the first instance? Okay, you know what? So this is what should have happened. So we don't need to import that since we already have ECS schedule here. So yeah, we've solved that, and hopefully doesn't really need a separate library like I assume you should not. So what I'm going to do here is I'm going to run this. Can't go wrong. I'm going to run breakouts, right? Because we already have breakouts in the main.rs. Now, one thing you've also learned from here is the way we add modules, and one module can reference another module. And that module can reference another module. So let me show you what I mean. If I want to use this now, let's say I have something like this. Breakout. In this case, I can have main because we already have the breakout module here. But this is not public, so we need to make it public. And the other functions too that are not public, we can reference literally everything from here if you want to. There are a lot of things we can reference, including the stepping. So breakout. But stepping, remember, is not public too. So but we should be able to actually render it because it's not there. But we can do that by doing this. Okay, no, we can't. We can't because it's not exposed directly. It's just exposed as a module, but we can still reference it. All we need to do is just make it available from stepping to breakout, and then once it's available in breakout, we can actually use it just like that, directly from the main, right? But that's not what we want to do now. So let's run this. Let's go to the main, run the breakout, see what we get, and if everything goes well, yeah, all well and good. We can now begin to make our own tweaks and see what happens. I believe there are some things that are not available to us. I believe there's a sound. I don't think we have that because there should be an audio source, but yeah, there is. I don't think that is loaded anyway. And yeah, exactly. This is the sound. So there's a sound collision.ogg that we don't have, and so let's see if we can get that actually. Assets, sounds. From assets, sound. Asset sound. Bit of UI is so broken these days, just so annoying. Breakout collision. Okay, so we can download the raw file here. So once this is downloaded, we can make use of it. So I'll just save this as breakout collision.ogg and pick it from here, my download folder. And add it to our assets. Okay, I'm going to create a new folder called sounds. Yeah, I'm going to paste it here. Breakout collision. Okay, not adding anything. So let's run this. I want it to have the sound. So we may actually talk about adding sounds too, but that's not actually what we are here to talk about today. We might treat that another time. I wanted to do this whole thing in just 7 series, right? From beginner to should I say intermediate? What is happening? Is my screen frozen? What just happened? My laptop frozen. Wow. Okay. So we have this, and you can see the sound works and literally works the same way as what we have there. So that means the fixes we implemented work perfectly well. So now this is another reason why we need to understand it. Now, without having prior knowledge of what this code is about, just looking at the errors, I was able to provide a fix for it because I understand this is how it works. Or basically, I understand how Rust should work. And then I understand how Bevy should implement its thing. So I understand that if there was something missing and there's an error, whether an import error or something that doesn't exist, a module that doesn't exist, I know I have to provide the module, even though I don't have access to it. Provide it, add it, and everything works as perfectly as it should. I don't know if you understand this now. So, um, so this is basically what we are trying to implement here. Now let's talk about the other things. Let's talk about every other thing we want to implement, which is the what we want to look at today, the collision and every other thing. So let's start with the collision. And as I said, the first thing we need is the bound, right? We understand the bounding circle from the diagram I have here, right? In terms of bounding and then intersection, right? So that's the first thing we need. So looking at that, let's look at where it is being used, right? So I'm going to assume and I was declared as variables. We understand how constant works. So I shouldn't dwell more, right? So I wouldn't dwell more on that because they're just constant and they are understandable. There are things we should use, right? So the main function too, it's actually not new to us. We understand how the main function works. We understand what it should do and what it will do just by looking at it. So because we do understand this now, we then see the normal thing as plugins. Then we enable this stepping, the stepping we added, right, that we copied and then we added to just to make sure the code runs successfully. Then we had something called a resource. We already understand how to add resources. We looked at that yesterday. A resource is just something you make use of within the game. Just like when you're trying to build a table, one of your resources that you need is your hammer, or you need a drill, right? Or you need a screw, you need screws, you need a measuring tape. Those are resources you need. So when you are building a game, also you need to identify the resources you need for use within your game. So in this case, one of the resources we need is a score. And in this case, a score is simply a struct, yeah, which is a component because we are deriving it from, or is a resource in this case, not a component because we are inserting it as a resource. So this resource tracks the game score, right? So we can implement something like this for the game we did yesterday. Now we are saying now we are building on the previous knowledge now. So we are building on prior knowledge as we proceed every part of the series. So talking about the score is just a resource, right? In this case, it's a struct that is a Bevy resource, and it derives the resource trait, it derives the deref trait, that's the reference, and then it derives the deref mutable trait also. So we have these 3 traits. We don't really need to understand what those two does. We just know that we need to derive it for our use case. So in this case, we need the score, and then we need the scoreboard UI as a component this time around. Now, going back to, let's go back to the main. Those are one of the things we need. Then we need the clear color. The clear color in this case is just another Oh, yeah. This is a resource also that's available to us by default from Bevy. Now it says a resource that stores the default color that cameras use to clear the screen between frames. Right. The color appears as a background color for simple apps when there are portions of the screen where nothing rendered. So individual cameras may use clear color to specify different color area or opting out of their viewport. So that is being used also. That's so that between renders, it actually removes it without you seeing whatever is happening there. Then we have the startup, which is our setup, always our setup. And our setup is where we define most of the things that will be spawned before the game starts to update at any point in time. So on first render, we want all of this to be available for our game to use. So which means the first thing we do here is simply to add in as usual our command, meshes, material, and the asset server because we are going to be making use of assets for our audio. Our audio in this case is an asset which we've added now. That's why you can hear the sound, right? You can hear this sound. The, yeah, that sound. Yeah, that's the sound. So that's the use for assets in this case. And as you can see here, we can see it from the asset server.load. It's basically taking the asset and we are using it here. So the next first thing we do is, as always, is to spawn up our camera, right? In this case, it's a 2D implementation, not a 3D game. So we do not need to spawn a 3D. We do not need to spawn a 3D camera for it. Just a 2D camera is fine for our use case. And then after spawning that, we define our sound. Our sound is just inserting or loading our assets and adding it as a resource. In this case, we're adding it as a resource of collision sound. Collision sound is coming from here, which is we already defined as a resource also. And we are using this undo. Undo basically is coming from Bevy also, and it's an enum that tells us, excuse me. So it's an enum that we use to specify the asset type. In this case, we are specifying the audio source. The other types that we can specify. So basically, the other asset type you can specify. In this case, just asset. Asset also has its own type and is implementing the traits of asset. So we're using that collision sound within our game, which is here when we are setting up, defining the collision sound that we want as the ball collision sound that we've loaded from our path, right? Then we have the paddle. So the paddle here is we are defining the paddle Y. In this case, just the dimension of the paddle by saying the bottom wall plus the gap between the paddle. The bottom wall is, if I see 300, as you can see here, the bottom wall is 300 minus negative 300. So the paddle is 60. So we are simply saying the paddle Y in terms of like the positioning of the paddle in terms of the y-axis should be the bottom wall plus the pad between the paddle and the floor. So the bottom wall in this case is this this lower gray border, lower line, this gray line that is down here. That's our bottom wall. So it does minus 300, negative 300 plus the 60 in this case, which is negative 240. So that means our paddle Y is going to be defined in negative 240. That's why you see it's not at 300 but at 240. So it's just calculation, yeah. So then we spawn the sprite also. Now in this case, we need sprite. But what is the sprite? Remember, we are not using an image as our sprite. In this case, we are using just this. We are using where's it again? We are using this as our sprite. This as our sprite. So what are we doing? We are defining the sprite by using the paddle color. The paddle color we already defined, and that's why we have this bluish color. Right. So we have the vec1, which is we are defining the color, right? So we are using the color and the size in this case. So we are using this vec2, which is our two-dimensional vector 1. We are using it to define just to have it as 1, like in terms of like what's this word? We are using it for the dimension, that's the width and height, or no, just the dimension of the colors rather, not the width and height now. The color scheme, the color scope, everything is just 1. So it doesn't have any other color. So it's just going to be one single color all through. So that's what this from color does. We have the paddle color, which we already defined to be this color, right? And then the size of the color is what we are defining. You may be wondering what's the size of the color for. So we are creating a sprite from a solid color. So we need the size of that color for the sprite. And the sprite is just it's just like you building multiple pixels of something. That's what a sprite is in this case. So that's why if you look at our game, you can notice that it's just a block, right? So that's that. So we have to transform. Remember, I said that we need what we do here basically is transformation. We transform this. That's what we have for our padding, our paddle, right? It's basically transform. That's why we can move it. So because of that, we need to define a transformation for it, an initial transformation for it. And remember, we said we wanted to define it somewhere. We've already determined the y position, so we can create our transform struct and define the translation and the scale that we want for it. So in this case, we are defining the transformation as a three-dimensional vector that has x to be 0. So that means it starts from the middle. The y starts from negative 240, just like what we calculated from here. And the z is basically 0. So that means it doesn't have any z index or z height defined between any other object. That means it remains as 0. So the scale is part to size extend 1. So that means the scale is 1. So we are not extending the scale. Just to make it clear, if I extend the scale to 2, notice the size of this paddle now currently. If I extend the scale to 2, I can. Now watch what's going to happen. It's going to become bigger than what it is currently. Now, I don't know if you've played some of these games before, like the actual games that when you collect a power up, it makes your paddle bigger, right? In this case, that's basically what this does. So you are scaling it, but you notice that something has changed here. Okay, let me do something here. What value should I give to it? Okay, let me give it 10, right? And then we start this. This doesn't seem to change. Is it my eye or something? It doesn't really change, right? I wish I was changing the right thing. Yeah, this is a paddle. Yeah, that's correct. Let me be sure. Let me check this. Let me put it below. This should have worked. All right, probably missing this. What the extend does for the paddle, because we are creating a 3D vector from self and giving the z index. And we are scaling it. Yeah, maybe this is probably not needed then, because it doesn't add anything to it. So but we understand this basically. So if I do this now, if I let me restart this so we can see where it starts from in terms of the translation. The scale doesn't seem to work. Now this is not it doesn't seem to add anything to the transformation. You can see start from the middle of the screen. Now let me make this change. Let me change this to, let's say, negative 40 and then render this. Now you can see it doesn't start from the middle anymore. We start a bit from the left. To make it extremely obvious, let me change it to 100. Now you can see. So it simply means that the translation works. But one thing I want us to also notice is the position of the ball, right? Where does it start from? Where does it move to? Remember, I mentioned that there's also that configured for the application where it moves to. Now let's implement that and see. So I'm going to rerun this. Notice that you can see that it moves downward, right? Not upward. So, and to the right also. So let's see it again. the same thing. It comes to this side, right? And that's going to come in handy as we move on. So automatically we understand this spawn for the paddle color. Let me reduce the volume. So I'm going to set it back to 0 because we want it to start from the middle of the screen, right? But the paddle starts from where it should start from. Then we have the paddle here defined, which we want to affect with when we spawn this. We want this paddle to take all of these configurations, right? And then we have the collider. And the collider we said is a struct, right? And we say it's a resource, as we already saw it the other time. It's a component rather, not the collision sound. So this is a component that we already have and that we make use of for the paddle. So we implement the collider in this case. I remember we defined the collider for during our main. There's the main implementation. Okay, no, I'm thinking of the collision. So we have the collider in this case. So we have the collider defined for it, so that we can make use of this collider stream component or struct whenever we are trying to define what this paddle can do also. So let's implement the ball. We understand what the ball is going to be. It's just a mesh 2D, right? In this case, just a circle that we created. It's the basic material of the ball color. There's no crazy composition. There's no crazy transformation. No crazy material rendered for the ball. So then we have the transform also that defines the starting position of the ball. So in this case now, we define the starting position of the ball as our vector that we defined before, which is -50 downward, and we have the z index to be 1. So that means it moves by that particular one. Actually, so in that of calculation, this is what we define for it. So that's the transformation here. We scale it with this diameter, and then we extend it by 1. So we have the ball defined and we have the velocity. Now in this case, now the velocity is going to be just as an actual velocity in physics works, right? So this is the velocity, the movement of the ball, right, with respect to the speed at which it moves and the direction. So we are talking about the speed of the ball and the direction which it moves, which gives us the velocity of the ball. So not just the speed now. So we are not working with speed, but because we are controlling the direction, or we are not controlling it per se, but the collision is controlling it, we need to also put that into perspective. So going to the velocity in this case, we talk about the velocity from here. I will define the velocity to be initial ball direction, the normalize this, multiplied by the ball speed. Remember we said velocity is basically what? The speed and the direction, right? Just technical basic physics, normal physics, nothing too different. So in this case, the velocity struct defines or takes in a two-dimensional vector, which is a vec2, and it's being used by passing in the direction we want to move towards, right? And the initial ball direction is what? Our normal vec2 of negative 0.5 for the x-axis and negative 0.5 for the y-axis, right? So that means that's why it drops. It drops because it's coming to the negative y-axis, not to the top. That's our initial ball direction. So we are normalizing that ball point because we are taking in a two-dimensional vector. We have to normalize it so that we can multiply. We can use the multiplication operator on that vector. So normalize the vector and then we multiply by the ball speed, which is defined as a floating point integer also. So that's the basic thing we implement for the ball. So right now we've done the paddle and the ball. So let's look at the scoreboard. And the scoreboard is just text. So basically from what we've seen so far and what we've implemented from all part 1 of the series, we've always used text, right? So this is also text. You can see score 55 here, which means we are working with text. But the text has 2 different colors, right? So let's do something here. First thing we're going to do is we're going to define the text or new as score, which is the score here. So we define the colors for it because the font size, the colors and everything, because it's not a default color of black. So define the font size, define the text color, then the scoreboard UI is just the scoreboard UI, if I'm not mistaken, is already predefined. It's a struct that we can use, right? that we already defined here as a component that we can use to determine how the scoreboard works. So that means we can implement a function for it, and then we can use that function within our logic, right? So that's what a struct is. A struct is just a data type that allows you to group stuff and define logic for that particular group. So we have a scoreboard defined for it that we can use, or we can call this. We can call all of this a scoreboard just because we've defined the struct for it. Then we define the node that defines the position of the text itself. Then aside from that, we also have a child, or let me say the children, that also defines the second um, font. In this case, you see that we did not create 56 anywhere because 56 keeps changing. It's not a constant, right? So we can't define it as a text. So what we did was define the children for this original text called score, and define the child as text span or default. Text span in this case is a span of text in a tree of spans. Forget the old English there. It's just a way of adding a text to another text. That's basically what it is. And then you have the text font, which is also for a way of configuring it, and the text color. Now you see that the text color is different from the score color. The text color is the whole bluish thing. The score color is the whole pinkish, which rhymes with the ball color, right? So we define those things. Now we define three things on our game. We define the score, we define the walls. No, we've not done the walls yet. We define the paddle and the ball, aside from the camera and other things that we want. Now let's talk about the walls in this case, which is justice. Now the wall is basically just we spawning a wall. A wall in this case has been defined as a struct, right? Because we want to define it to be able to do stuff. So in this case, now we define our wall as a component. Now look at what is here. It's a collection of the components that define the wall in our game. So it's a component because we want to be able to initiate logic for it, right? And it's a struct. So that means we can implement different functions that we can call within the struct. So we have three things defined. We require three things for the wall. We require it to be able. We require transform, collider, and sprite. So basically, we want to define our wall as a sprite. I want to be able to transform it. We want to be able to add the collider to it. Remember, we added the collider to the paddle also. So that means you should be able to collide whatever it is that we want to be able to collide with it. You should have that collide property that we can define how it should behave when something collides with it. Remember, a collider is just a structure defined here, right? We've not given it any implementation yet. So that's basically, aside from the default implementation gotten from component and default, it doesn't have its own custom implementations. So which side of the arena is this one? Okay, no, that's not what I'm talking about. So we have an enum called wall location also. An enum for wall location is left, right, bottom, top, which are the four different locations we have for the wall. And we can implement that wall location by implementing the position, the size. Now you see where it becomes interesting. And like I said, we also need to we can implement other functions for the wall, which we also did down here by implementing the builder method for it, which is let's say this is the constructor. In this case, if you're familiar with other languages that use that. So we have a constructor called new that defines the location of the wall and returns a tuple of the wall, sprite, and transform. Remember, we say a wall requires these three things, right? So those are the three things we need. So we return the wall. So that means we need to create the wall by using new, by passing in the location. So we want to define the location. In this case, the wall location is coming from the enum that we define here. So that means there are only four states you can pass into the wall location as an enum. And you need to implement it. So that means we can use wall location dot position because we've implemented the location now, the wall location. So this is just the location of the center of the wall, which is used in the transform dot translation implementation or property in this case. So we have the function position, which is position of self, and it returns a vector 2. That means it returns a two-directional vector, a two-dimensional vector. And then we do a match on it that says if the wall location is left, right, define vec2 new, left wall, and y to be 0, which means this is the x-axis, this is the y. So what does that mean? It means that whenever whenever we call position on any of these enum or wall location enum, and we define the position, we are simply checking the position that we are talking about, right? So that means if you pass in left to it now, if you pass in left, it simply means we are talking about the left one. We are defining a vector for it. And that's why it's returning the vector 2, the two-dimensional vector of x and y. So when we talk about wall location on left, it's just for a way to make it help. It's just an helper function in this case that we can just call wall location dot position and passing the position we are talking about. So let's say left. So if I say wall location dot position and I pass in left to it, which is this enum, that means wall location colon colon left. I'm simply referring to return me a vector of X and Y. And the left wall here, you remember, is minus 450, negative 450 that we looked at the other time. And the right wall is negative 450. So that means we can define a vector of x-axis as negative 450 and y-axis as 0. So it will move it, it will define it very far to the left since it's negative axis, and the right one will define it since it's a positive y or positive x in this case. So the same applies to the bottom and the top, right? So this is just for you to get the position. It's just a way to, we'll see this in action below the code. So we look at the size. The size in this case now is just the x and y dimension that are used for the scale, right? So in this case, we do the position is just a way of, it's just used for the translation as we talked about. So we won't bother much about the size yet because we don't really need to bother much about it, but we'll talk about it though. So what this does is just we talk about the arena height, which is the top wall minus the bottom wall. So that means we need to first consider what is the height of where the game is going to be played. Is between this and this, and the width is between this and this. So we need to calculate the height here and the width here, and that simply means 450 minus 450 plus 450. Right, we know that this will give us 0, it will cancel out here, but that is not the way we are going to do it. We are going to look at the top wall minus the left wall, which you can see here is the same thing I'm talking about. Top wall minus bottom wall, minus 450 minus 450. In this case, right, that's negative 450 and positive 450. So that's going to give us the arena width, literally. Yeah. So make sure we haven't messed up our constant. So we still have our constant, and then we just do an assert to be sure that the arena height is greater than 0. That's basically what we are talking about in this case. So I believe you understand what is happening here, right? What is happening here is just your right wall is 450. So you said 450 minus 450. So that will give you 450 plus 450, that's 900. So it simply means the difference between these two is 900 in terms of width, and in terms of height is 300 300. So the difference is 600. So it's, you can say it's a 900 by 600 dimension square. So that's basically what we are calculating here. So the match self here is we are doing a check, just like an if statement. Like I said, this is like a switch statement in JavaScript or TypeScript, and like a match statement in Python or if statement. So the match here matches the similar Python syntax that you're familiar with. So if you're coming from Python or you're coming from any other language that use match or if or case or switch, Java, whatever language, this is same thing as a switch statement, right? It's basically stuff, the same thing. So the next thing we have here is the wall location left. Now imagine what I was talking about. This wall location on the left here is you referencing this, right? So it gives you an enum. You can't define any other thing aside from that. So if the wall location left or wall location right, we are simply saying that the vector 2, which is the two-dimensional vector, a new two-dimensional vector should be created with the wall thickness of 10, and the y dimension should be what? Your arena height plus the wall thickness. So that means if you are talking about either the left or the y, create a wall thickness of 32. Create a new vector 2 components for x and y. So at the x-axis is going to create it as 10, and the y is going to be the arena height plus 10 also. So that is how we define, or that is how we create this. So we are simply defining the arena height. The height is what? The arena height in this case, we already know is what? 600, right? So it's going to create it 600, and it's going to give it x to be 10, which is the width thickness. The same thing applies to the bottom here, just to be able to define the size of our wall location. So that's basically what we are talking about here, right? So yeah, so the next thing to look at is to look at the wall and to implement the wall. Now in this case, implementing the wall here, we need to look at the two functions that we define also. We have the new function that is implemented for the wall, and then we also have, okay, that's basically what we have, right? We have just the new, because the new is just a way of instantiating a new wall that we already defined. But remember, for the enum that we have, we've already implemented functions for it also that we can call to make use of it directly. So that's what we are talking about here in this case. So we have the new wall implementation that we can use, and that's what we are talking about in this case. So let's look at the function itself, right? So the function here is the wall location. We are taking in the wall location, which is an enum that we've already talked about, and we're returning three things: the wall, the sprite, and the transform, right? So those are the three things we are defining in this case, or returning basically. So this returns to us the wall. It gives us the wall, right? We need to pass in the wall, like I said, and we need to return the wall too. So we need to return the wall, the sprite, the transformation in this case. So what transformation are we returning? We have the wall here, which is this, and then we have the sprite in this case, which is coming from the wall color, right? We are defining the sprite just the same way we did for the paddle. But in this case now, the wall color is what? That gray color that we talked about. Then we are just finding it as 1 in this case. Then the transform now, we are saying, okay, so for our transformation, define the translation for it by extending the location and say location dot position dot extend dot 0. And then we have the scale also, right? So that's basically what we have. Then the dot default. So that way we are returning these three things whenever we pass in the location automatically. So that's basically what we are implementing here. So that's basically it. Right. So the same thing happens in this case, and the same thing is what we are talking about here too, as well, for the wall implementation. So the next thing we need to talk about is, so we need to look at this, which is the score, right? So we've already talked about that there's a score struct, which you take in a size, which you update, right? And then you have the scoreboard UI also, which is another component. But we know that the score is a resource, basically, that we make use of. And the resource takes in the deref and the deref mutes, right? So which is what we have. So we have also this component, which is the scoreboard UI, that we need to update, but we've defined it as a component, which I already showed you guys. Then the setup also is basically the same thing as what we've seen so far. So what do we need to now do next? Now the implementations directly. So from the setup also, we've looked at how the text comes. We've looked at the text. Then we also need to look at the walls also. So in this case, what are the walls now? We need to now spawn, which is what we have to check all of those things. So we need to check how we spawn the wall by looking at wall new and wall location left. So that's how we created the wall. So we created the first one, which, like I said the other time, all you need to do is just pass in the wall location enum to it. And once you pass in wall left, what happens? It does all of this calculation that we spoke about, which is this and this, basically, right? So we see the reason for all of those calculations. So whenever we pass the position, it takes in that calculation, takes in whatever we pass to it as self. Self is just a definition of the actual enum. So that's what is happening here, basically. So we say new location, we create a new wall by passing in the location. So when we do the new wall, I will check this new, we are passing in wall location. What does that mean? It returns the same wall that we just passed in, and then the sprite also. So that's basically what we have. Then we have the transform also. So the transform is just a way of converting our vector into our vector, which we've already talked about all of this. All we need to do is give it a z coordinate, right? So, and we don't want to dwell more on this. We've already talked about this. So, yeah. Okay, so look at this now. The error we are getting, why this was not expanding the other time or doing any changes, was the z scale of 2D object must always be 1, or their order will be affected in surprising ways. This is an issue. I don't know if it's fixed or not, but let's just proceed. That's not our bane of concern for now. So we've already spent much longer than I want us to here. But the next thing to check here, the next thing to focus on is the bricks. Now the bricks in this case are basically these guys. Let me reduce this volume. Okay, the bricks cannot be displayed here again. Let me rerun this. So we'll see the bricks. The bricks are those guys at the top that we can eat and get out of the view, basically. So what do we mean by that? So we have this, let this render, so we'll see what I'm talking about. These are the bricks, right? So we are taking away the bricks, so we are breaking the bricks. That's what it means. We can add breaking animation here to them whenever the collision happens. Those are certain things we can do, but those are just like assets that we can implement as we proceed, as we go on. So those are certain things that we can always add to it. But for now, understand the foundational implementations and the knowledge that you need to implement something like this. Then you can talk about adding more paparazzi, for how it is being displayed, and all of those things. So these are the bricks we are talking about next. So for the bricks, we need to consider their width, the number of widths, and we need to also render them. Remember, we need to render multiple widths. In this case, they are like 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 7. So they are 7 by 1, 2, 3, 4, 5, 6, 7, 8. So that means 7 rows, 8 columns, right? So let's look at how that is being defined here. Let me collapse this so you have more room space. So for the bricks, we define the total width of the bricks is, we already talked about the total width here. We calculate that by subtracting the left wall by the right wall, subtracting it by 2 and multiplying by the gaps. So that simply means that we already know the distance between the left here and the right here is 900. So what we are saying here is 900 minus 2. That will give us what? 898. Then multiply that 8 by the gap between the sides. Right? Does that make sense? All right. So that's basically what we are talking about here. So the total width of the bricks is what we have. The bottom edge of the bricks, excuse me, is the paddle Y plus this is what we have in this case. And then we have the total height of the bricks, the top wall minus this, minus this. Then we are start to do our calculation to be sure that we are not missing anything or nothing is broken out of at this point. So we can get a graceful decline of starting the application so that when we start the application, it doesn't break, or when we render it, it doesn't just break. It breaks before you even start that. So given the space available that we've already calculated for the total width of the bricks, we compute how many rows we can fit into it. So now to see if this is dynamic enough, what we can do is we can expand it. You can say, because we are not doing it with respect to the window, we created the dimension where it can render. So it scoped that same dimension, right? That's basically what we just did. So we can do that, and we can see the total space here, total width basically here is the brick size dot x. Now, these are just constant that we've already defined at the top. So it's just a way of not having to see numbers everywhere. It can get confusing. We see like 100.0 plus this. It becomes like, wow, are we doing mathematics here? Which, yes, we are, but this is a bit cleaner as long as you remember the dimensions for your object or for your entity definitions. So then we have the gaps that we define for them. But in this case, the first thing we did here was to define the columns. How many columns do we have? In this case, we have 8 by 7, 7 columns, 8 columns, 7 rows, right? How many columns do we have? We took the number of bricks, total width of the bricks, and look, what we did first of all was 900 minus this. Okay, so this is going to be multiplied first, right? 2 times this. The gap between the bricks is what? Let's consider the gap. The gap is 20. So that means 2 times 20, that's 40. So we subtracted 40 from 900 to give us what? 860. So that means the total width that we are working with is 860. So we say 860 minus the brick size. The brick size is a vector of 103. So dot x will give us what? 100, right? So the gap between the bricks is what? 5. So what we are simply saying is what? That means divided by 105. So this is the calculation that determines how many rows we define for our space. We don't want to define the space. We want it to be dynamic enough so that we can use it as we intend to. So that's simply what is happening here. So here we are defining and saying brick size plus this. That's where we're giving it all of those dimensions and definitions. So let me just complete the setup then. I will talk about this one and then we can proceed so that we can understand it. So then the end rows, we define the rows also. All of these things are just calculations. We can always pick this on our own and check it out, read it, try it, and see. So what I want to do is I want us to add some certain functionalities to it. I don't want us to do more on this. All of these are just calculation on how they are displayed. Then this is the loop that displays and positions them based on the number of rows that we can have, right? And we can see it being used where based on the end columns that we have here. You can see the left edge of the brick, and we can see the end column being used and the end rows being used. So we are defining a nested for loop for the number of rows and columns. Since we've already calculated it, we know what's supposed to happen. And so we use that to define the sprites as the blocks as a sprite, the same way we did for the paddle. And they apply the transformation. Then we define the brick component, in this case a struct, and then the collider. So that's basically what we define for it. So that is what we use, and that is how it is completely implemented. So the next thing that's important here is the move paddle. How do we implement the move paddle? The move paddle is implemented by just defining how the paddle should move, right? Based on the keyboard input. Remember, we always have this button key code getting input key code for whenever we want to implement the keyboard input. So that means we implement the same thing and we apply another function. This function is just to tell us what transformation we want to apply. Is it left? Is it translate left or translate right? So that means when we define our keyboard input and we press the arrow left key, we are simply saying move the direction by 1. Remember the direction initially was 0 by 0 on the x-axis. So we are saying that whenever we press the arrow left, increment the dimension by -1. That means move towards the left axis, the left x-axis. Then the same thing for when it is y, for when it is on the right arrow, move towards the positive x-axis. So we calculate the new horizontal paddle position here based on the player's input. So what does this mean? We have a new paddle position. In this case, we apply the paddle transform dot translation dot x plus direction dot paddle speed, and basically this is calculation. Calculate the horizontal paddle position based on the player input. So that means whenever you move, right, we are implementing the translation for the paddle. Remember, the paddle position is just a transformation with the paddle that we define on the paddle itself. So we define this paddle when we during the setup, when we are spawning the paddle itself as a paddle entity, we define this paddle on it, and we are using that paddle with the transformation by saying paddle transformation or translation or x to the new position, but we clamp it so that it doesn't go outside of the bound of the containers. Now, so far we've not spoken about the collision. So far we are just talking about the implementation. Now, how do we talk about the collision now, and how does that work? The first thing is we apply velocity. What is the applied velocity here? Let's look at how that works. So the first thing we see here is we have the transition.x.y, which is the velocity this. Let's not talk about this first of all. Let's look at how we update this cobord. Updating this cobord is very, very easy. We define this core as a resource. We define this core root, which is the entity for the scoreboard UI and the text. And then we define the writer, which is the text UI writer. And then we say writer, which is this dot text, is just going to be score root 1. That's the first index of the score root. The score root in this case is our scoreboard UI that was defined here. So I'm going to take it back here with the text. So the text, we are simply saying dot text, writer dot text, write the score root, which is whatever it is that the scoreboard has with the text, and pick the first index, which is the first child. Okay, yes, and add the score dot to string to it. Now the score dot to string here is just the score that you get, that you pass into it when you update the scoreboard. So in this case, we use the update scoreboard here in the apply collision. Oh no, at the game update, that's where it's going to happen. So now let's check for collision. This is the main thing that I want to look at before we start making updates. So checking for collision basically means that this is the main thing. So checking for collision is where we now want to implement all of those bound positioning and stuff. So like I said, remember the bounding circle that I explained the other time, this bounding circle, this is where we now implement it. So let's talk about collision. How do we check for collision? If I'm to check for collision for this game, I need to consider certain things. The first thing is I need to check what is it colliding with, right? I need to check the position of the ball with respect to the object it's colliding with. So now let's look at that. The first thing we have is our command, which is normal. We have our score so that we can update the score whenever collision happens. And then we have the ball query. Like I said, we need the position of the ball, we need the position of the ball, and we need to be able to determine what has happened, when collision has happened or not. So that's the first thing we need. Then the second thing we need is the collider query. The collider query in this case is what helps us to understand what it has collided with. And that's why in this case, for the ball query, we have the velocity of the ball. Remember, we define velocity as the speed and direction. So that means the ball is moving to a particular direction, and the position of that ball, we need to know it. Now, we don't really care about the speed in this case, but we care about the position. But we need to know that velocity contains the position of that ball. So we have the transform also, and we have the with ball. That's why we're adding the ball with it. So we are querying the velocity, the transformation of the ball, right? And then the collider query is just re-querying the entity, the transform, the brick now that is going to be colliding with the collider struct. So what's the first thing we do? First thing we do is we destructure the query itself by saying ball query.into inner basic Rust, normal Rust destructuring. We do that. Then the next thing we do is we say for collider entity, that's collider entity, collider transform, maybe brick in collider query, which is this guy. So So the first thing we do in this case is we destructure that collider query also. We destructure the ball query. We also need to destructure the collider query. And we do that by taking all the components that are returned from the collider query. In this case, the entity, the transform, the brick, right? But we still have the collider with it. So that means we can still access the collider within the query itself. So let's see how that is being done. So for the collision itself, which is the important part now for what we are discussing today, is we start with the collision, right, which is the ball collision in this case. And we start with the bounding circle, and we start with the AABB2D. In this case, what that means basically is that, okay, let's talk about the bounding circle first. The bounding circle in this case now is just a struct that helps us to define, okay, we are defining the bound, just the same way I drew this for us. So we need to define the position, or let me say, we need to define the radius of the circle that we are trying to bound. In this case, the way I defined and defined the bound for this circle is the same thing that is happening here. So we define a bounding circle, which means we define the bound. We first need to get the translation, which in this case, remember, is going to be x, the center of the object we are trying to bound, right, and the radius of the circle that we are trying to bound. So which means we have the ball transformed or translation or truncate. The translation in this case now is a position. Remember, we said that the ball itself has a velocity and that's a transformation. So we need to first of all understand, since new takes in the center, so we need to know the position of that particular thing, of the center of the object that we or the entity we are trying to bound, which in this case it is the transition or truncate, right? Truncate means we are creating a 2D vector from a 3D vector. I don't know if that makes sense. Because in this case now, the translation is a 3D vector. Remember, we defined the Z position, which means what we gave it as 1, so that it is on top of all the other entity in our display or in the world that we define. So that was the first thing we did. So we needed to truncate it so that we could get the X and Y directly. So that means this gives us the center of our ball, the position of the ball, like what I explained initially. Then we define the diameter of the ball. The diameter in this case is the radius rather. We know, like I said, the radius is 30, so the diameter has to be 15. So we just divide the diameter by 2 to get our radius. So that automatically creates a bounding circle for us. So in this case, what this means is that for this thing we are trying to implement, in this case our ball, we need to create a bounding circle. We need to know the radius of our bounding circle, right? So let's say in this case now our ball, and this is going to be a bit not reasonable to implement. So let me define this. Let me get this. So let's say I want to implement another circle for this, right? But I'm going to increase the circle a bit. So I'm going to, let's assume I want to increase the circle a bit like this. So I'm going to change this color to maybe a dark green and then implement this. So let's say this is our bounding circle. I'm going to take this backwards, send to back. So the green is our bounding circle in this case. The red is the objects we are trying to bound, right? Because what this means is the radius of what we are trying to do. In this case, the ball diameter is our radius for the bounding circle. The reason why I'm adding this extra padding is because you can always add the padding to it. So let me show you what I mean. If I add the padding to this, a radius, and say that of 4, right? Like this. Now you will notice that currently this ball touches this, like it touches the object to assume collision occurs. Now let's see what happens when we rerun this, just to give us a sense of that radius and the bounding itself. Do you see that it doesn't touch the paddle anymore? Like literally doesn't touch the paddle because the bounding circle has been extended just the way I did this one. So if you want to do it even more, let's add it, let's make it 40. You realize that it doesn't even touch any of the existing objects anymore. If you look at the paddle where you realize it doesn't touch it like it was before. Neither does it touch any of the other things like it does before to get it to register it as a collision. So that's the bounding circle that we've been talking about. So I'm going to rerun this, right? Now I've increased the value to 40. So that means is going to be now. So when this is up, come up, come up, come up, come up. Okay. Now you can see as if it's floating in the air. You can see what is happening. It doesn't touch any of them anymore, and it registers as a boundary, right? So that's exactly what is happening. So that's what I wanted to just point out here. So the bounding circle, just like I drew it here, is what happens for our objects, right? This is exactly the implementation. So this one is just like a way to explain it to you. But for the actual ball itself, this is the bounding circle for the ball. The green is the bounding circle. You can add the padding to it so that it doesn't need to touch the object 100% before you register it as a collision. You can add the padding to it to make sure that, okay, before you even touches the object, yes, you've already registered that collision automatically. So now the ABB2D now is a 2D axis aligned bounding box or a bounding rectangle, which is this guy that I drew here. Remember I said there are two things, the bounding circle and the ABB2B that I explained is this rectangle that you can see here. Now this rectangle here also, you need to create dimension for it. But in this case, the ABB2D does not take a radius because it's a rectangle. It's not a bounding circle. So we have two things. We have the bounding circle, we have the bounding rectangle. So which is what we've drawn here, the bounding circle and the bounding rectangle. So this is the bounding circle. Let me add the text here. So let me increase this. So we have the circle and the bounding rectangle. So let's say rectangle is the bounding circle. So it gets defined automatically 100%. So this is what happens next. So this now, so for us to complete this implementation for the collision itself, remember the ball collision we defined takes in the bounding circle and the bounding box. Now, the bounding box, you understand, is the same thing, the box that surrounds the bounding itself. So now we need to take the position just the same way we did the position for the ball, but in this case, it's going to be the collider transform itself. The collider in which, in the case of the brick, we are colliding with. So in this case, we are colliding with the brick now, and that brick is basically also has a position. So we get the position of that brick because initially it was a vector 3D for the collider itself, which is, let me show you guys, takes in, where did we define the collider? Okay, it takes in the default here, which is where that comes from. But then it takes in a vector 3D, that's the collider transform itself, which is this transform we are making use of. Right? Remember we destructured this to get the collider transform. The collider transform is this transformation here. Now, no, I don't want to open this. So this transformation here always works with like Z, Y, and X, Y, and Z axis. So the collider transform we are working with here now takes in dot translation dot truncate. In this case, just the same way we did for the ball transformation. But we also need one more thing. We don't need the radius. We need the half size. The half size also can be, you can look at it as the radius, but in this case, a radius is for a circle and half size is just like the half of the rectangle, right? So it needs that so that it can actually draw the rectangle or you can draw the bounding box, right, by just knowing the half size of what it's about to draw. So then it uses that, and then we also, same thing, we take the transform, we take the scale, and we truncate it also to get the x and y axis. Then we divide it by 2, basically. So that's for the x. So that means we divide it by 2 by taking the, remember this scale is going to give us the z position. No. Yeah, it's going to give us, when we get that transform right, we can define translation on it. That's the position of the object, right? The position of the object. This is also going to give us the scale of the entity in terms of like, not the position now, but let's say the size. Let me just basically the size. The scale of the object is the location it exists in space, and the area it takes. Yes, the area it takes in space. Let's say in vector space. That's what the scale is. The area it takes in the vector space. So you take that and you divide it by 2. So that way, because you truncate it, you are getting your x and y axis. You can divide that value by 2. That means it returns half of the x and y axis. So given the bounding box or the bounding rectangle, the x and y axis, the half of it, it knows to replicate it to get the full box for you. and then you can use that for his own calculations as it needs to. So that's basically where the collision happens here. So that's what we want to look at to understand how collision happens. It's basically all of those things. Every other thing is just basically what we've done before. So we have this: if let some collision equals to this, trigger observers. Now remember the observers we created before for when we implemented the click to destroy game, right? Click to destroy game, whereby we use the trigger. Now, this is also something like that. When you trigger the ball collided, the ball collided in this case is what? This struct here, and it's defined as an event. So you can define the collider on it, the trigger on it. So you are simply saying that trigger this ball collided. So what is ball collided? Where else is being used? You will see where it is being used. So now brick should be despawned. Remember that despawn that we talked about, and increment the scoreboard on collision. So we're implementing the scoreboard, which you already defined from here, from the score. And then we reflect the ball's velocity when it collides. We reflect it by, now the reflection here is where it gets interesting. When he hits that, you can just stay there. But why does he always move to another position? Why does he change position? That's where the reflection happens. Now the reflection is when he hits something, move in the opposite direction. That's basically what reflection is. So in this is exactly what it is. Yeah, this is it. Reflects on the x-axis with something. So we change the ball's velocity from x to negative x and y to negative y when we hit something on the y-axis. So now the sound is adding that. We are not talking about that, but then the collision happens the same way. The bounding collision happens the same way. So what does that? When does the ball collision actually happen? So when we get the position of the ball, of the bounding circle and the bounding box, what we need to do next is we get the closest point. We say closest equals to bounding box the closest, right? The closest ball dot center in this case, then that's okay. So now the bounding box itself, that's the AABB2D that we already got, has a function called closest point. Closest point finds the point on the ABB that is closest to the given point. It's a calculation. So it gets the point on the brick that is closest to the given point, the point that we give to it. Now, what point do we give to it that it should get the closest point? That's the ball dot center. So we are simply saying get the closest location to the ball. So this is for the brick, right? So that means whenever the brick moves, let's say it wants to hit the paddle, for instance, it gets the closest location to the paddle and changes direction automatically. So you don't do all of these things. It's handled for us automatically, right, by Bevy engine. So you get that, but we also need to get the offset. For the offset, we get the ball dot center. We already know the ball dot center now, based on the fact that we already know the radius, right? So, and we already passed that as the bounding circle. So the bounding circle provides us the center function, automatically provides us the center function of the bounding volume. So in this case now we can select the side for the collision to happen. So if the offset is basically the center of the ball and the closest location to the brick we are trying to hit. So now we say that if the offset, that's the subtraction between the center of the ball and the brick you're about to hit, is the absolute value is greater than the y. Now the offset let me x dot y less than 0. If it's less than 0, the collision happens to the left. Then if it's the other way around, the collision happens to the right. Now this one is just a side check that you can do. If you remove this, you will see some of the implementations that happen here, but we need to pass side to it. Let me remove all of this. Oh, that's true. I need to change this. No, I will leave it. But basically what this is saying is that the side that you collide with, that's what it's trying to check. It's trying to find what side you collide with on the box itself. What side do I collide with? Right? That's what it's trying to find out. So do I collide with the left? Do I collide with the right? Remember, the collision is an enum that tells us the location that you collided with. So in this case now, if I collide with this, where do I collide with? We also keep track of that. So that's basically what is happening here. So bulk collision is telling us where everything happens. So that's why when we use this bulk collision here, we could get the response by saying the collision happens somewhere. So we use that collision to determine what to do. So if the collision happens and we match the collision by saying that, okay, reflect the X, right? That's why we're able to know where to reflect to, because we're able to get the collision. And that's what we're able to use for this also. So let me explain what this does now. So reflect only if the velocity is in the opposite direction of the collision. This prevents the ball from getting stuck inside the bar. So if the velocity is in the opposite direction of the collision, if the velocity of the ball now is in the opposite direction of the collision. So let's say in this case now, so the ball is moving like this, right? If the velocity of the ball is in the opposite direction, like when it hits this place, you can see that movement like this. I can only show you by showing the movement. It's easier to explain that way. So when it hits the opposite direction like that, you can see that when it hit the opposite direction, it reflected because it was coming down like this. It got this and it reflected. So it's simply saying that which position do I hit? Whenever I hit this brick, which position do I hit like this? You can see it. So it was coming, let's say this is our Y now. Coming down here is our Y, right? See what happens. It moved the other way around. This is our Y again, moves the other way around. This is our Y, it moves the other way around. So you can see what is happening. So it moves whenever it comes to the Y and it detects that yes, the collision hits the right, it's going to trigger that particular collision. That is spot on rather. It's going to reflect the velocity by reflecting it the other way around. So that's what is happening here. So that's basically the whole collision property and how it's basically been implemented. But we can add more features to it. It won't be fun if you just come and we don't add anything to it. So two things we are going to add to it. First thing is this: whenever there's no more ball to eat, we should see the game should pause and we should see a game over implementation. So I'm going to, like we did yesterday, we're going to use our AI to implement some of these features. So we're going to say something like this. I need this to be bigger so you guys can see it. Wow, 6 plugins. Let's see if I can increase the size. I want to increase the size. Plugins. No, not that. Okay, the size works for Klein, right? Klein is big enough. Okay, yeah, Klein is big. Kilo doesn't just want to respect the size dimension that I set on my editor. But basically, this is, so let me just use this to define. So I'm going to say, let's see if I can zoom this in. I can't zoom it in. Okay, let's see. I should be able to do that. Let me go to plugins. Oh, I can't do it from plugins. I have to do it from appearance, behavior, appearance, island. Yeah, I set the size to 20. Use custom font, system settings. Let me reduce this sound so it won't disturb you guys. So we have the preset. No, not that. The editor, general editor appearance. Yeah. So we have this to be. Okay, yeah, so this is it. I wonder why it is not working. Let me apply to see if it's going to register it. Well, it still doesn't register it. All right, I tried. So doesn't work with our fonts, our plugin font, which is strange. It should. For some reason, it doesn't. Okay, so let me just ask you what to do. So this game doesn't end when all the bricks are completely destroyed or despawn. We want to end the game when there is no brick, when all the bricks have been destroyed. So let's assume that let's use that as our implementation, right? So the next thing is we are going to just ask how it's going to implement it. We are going to look through it and we are going to implement that. So basically, what it's supposed to do, what we are doing is that when you despawn this, right, we need to have a of if the game is completed or not. So that means we know the number of rows and columns. We can simply use that as our check. We know that our row is 8, our column is 7, but it's not static. It's depending on the size of the window. So we can get our rows and column and always check whenever the rows and column update and say things like, okay, if our row and column update, and sorry, if our column row and column is multiplied by 7 by 8, which is 56, if the total score is 56, end the game. That's one possibility. Another way we can check it is we keep track of the same way we keep track of the count of the game whenever we eat anything. We check if there's nothing to eat anymore. So there are multiple ways you can check that also, which everything still boils down to the number of breaks, right? I think that's the best way to do it. So after we use that to check, it's still the easiest way to do it. We can just end the game. So yeah, so let's see what the AI gives to us. To analyze the code base, understand the spawn bricks when it eats whenever checks and bricks are gone. To blend the game condition to track number of bricks spawn, decrement the number. Okay, check after is structure. Okay, so this makes sense. But in this case now, it's going to do a lot more work because it wants to track the total number of brick spawned, which is still based on what I just explained, the row and the column. So we check the row and the column, which is 7 times 8, which is 56. So whenever the number of bricks increase to 56, we need to keep track of that. We need a state to keep track of that. We just display an end game. Game ended, you win, or something like that. Or we go to level 2. Now, those are things we can do. Now, we already know how to create different screens. So we know how to create different levels for our game if we want to do that. And I think that would be a good thing we can implement. Implement a level system. Level 1, level 2, level 3, level 4, level 5. Right? I think that would be fun. So yeah, those are things we can do, but we don't want to write that by hand. Like I said, I'm going to also show you that AI is part of your workflow. So don't shy away from it, embrace it, use it, and make your work faster. So that's what we are doing at this time. We are using AI to implement it. We know what to do. We know if it's right, wrong or not. So we can use it to guide ourselves to be faster. So in this case, I'm going to say yes. Based on what it has suggested, it aligns with my own what I think should be done. So because it aligns with what I think should be done, I will tell you to proceed and complete the implementation. So he wants to do the same thing I've mentioned. So he wants to know what should happen. Should I display a you win message or just stop the game loop or pause the game or restart option so the user can restart. So I want it to do two things. I want it to show a you win message and a restart option. So once this works successfully, we can now implement the game level system whereby we make it more complex. Probably we add more levels of rows and columns. We can do that, yeah. So the rows and columns is just what's going to change. Eventually, we can implement a layout system whereby we implement the bricks in different layouts. Currently, it's just a normal row and column layout. We can implement it in zigzag format so it becomes more difficult for the game, and we check the time. Do you understand how this thing play out now in an original game? Because currently, once you can implement a simple one, you can think of how to implement the other one. So in that case, all you need to have is have a layout. You can always check how to implement a layout from the asset, pick an existing layout, read it, understand it, bring it to our game, and implement it. So anything I'm showing you here is how to pick what already exists, learn from it, implement it to your own. But you need to understand how Bevy works first. And I believe the first 6 part of this series is the easiest way to go forward if you want to continue understanding Rust, because everything we will write is basically use Bevy. Definitely. So that's what we are trying to do. So I'm going to tell the AI to just show a UE message and restart the game, right? And a restart option so that I can click the restart option and restart the game. If everything works well and it's able to implement it completely, what we are going to do next is simple. We're now going to implement the level system, a very basic level system whereby the rows and column just increases. That's an option. You can do more, but let's stick to that for now. So if we can do this today, we successfully completed what we plan to do today, which is talk about collision and understand how it works. And I said yesterday, which we've checked today, is we need the bounding and we need the bounding rectangle and the bounding circle. And if you understand what I've explained from here, this is basically an instance of the bounding circle and the bounding rectangle, right? So this just it's not this is an almost perfect implementation of almost perfect representation of the bounding circle and bounding rectangle. In this case, the AABB2D. The bounding rectangle is the AABB2D. We call it bounding rectangle, or we call it AABB2D in Bevy, but it's most likely another word for it is the bounding box or the bounding rectangle. So this is how it works. So the bounding circle in this case is this green aspect that gives you can decide to collapse it completely as the size of the red, so it doesn't have any external thing. But we added the padding to it so that you can actually extend. You don't need to directly touch the object to determine to register it as a bound or as a collision rather. The same thing applies to the rectangle. You can increase it by adding a padding to it to determine that okay, it has hit something you are planning to hit by tracking it. So you can see how all the pieces comes together from what we've done from day 1, day 2, day 3, day 4, day 5, which even yesterday, which is part 5, we did the we checked observers, right? We checked observer in part 4. So we've used observers in this game. We've used the assets. We've used despawning. We use how to despawn. So we've checked how to despawn objects. So we've used that also. We've used the assets systems. We've checked resources. We've checked plugins by adding another source code from plugin. And now the last thing we are checking now is the collision. So this gives us an idea of how everything can work. So let's see if the AI has already added some of the things or he has gone to hallucinate again by removing some of my code. I can see errors already. Oh Jesus. Okay, so the first thing is he added certain things. Let's see. So he added a game restart event to it. Probably should have told it to plan before adding any of these things. I'll have checked it first myself. Okay. Undo break this spawn, observe that in the system that checks that. So it implemented all of those things and removed something from it, and I'm not even impressed with this because it doesn't even do anything and there are errors already. So the component is not even implemented for this because he removed it. So let me run this. You should figure out that it's not implemented and fix it. So I believe this helps, right? This whole thing by now should help in terms of what happens or what you should see when you check it. So that's basically what we are talking about here. So this is the part 6 of the series. This is how it's supposed to work. This is how it's supposed to go. So hope you guys have learned something here today, and I would really appreciate it if you guys drop a comment to indicate if you've learned something or there's something else we didn't talk about that you think we should learn, or even there's something we missed out on or I was wrong from what I said. Just feel free to drop it out because, like I said, we are all learning. I don't have all the information, but at least I believe I've done justice to it to an extent. So for everything that you've learned so far, if there's any other thing you should know or you feel like you don't know yet, feel free to drop a message. You can always do a revision video on one particular aspect and then we can talk about that. So yes, before we complete this, where is this coming from? Why is it picking observer from there? It's supposed to use just one. Let me check if he implemented that. Did he import anything? No, it didn't. Okay, that's fine. Okay, so let's check if the AI has been able to complete whatever I wanted to do, right? And see, that's everything that's been done in a few minutes. I'll show you guys what it was able to do. Like, we can always check it out to be sure. Let's see if our game runs. I want to trust what it has done. Let me give you the benefit of the doubt. Okay, let's just play the game as fast as possible, see the result. So another thing we can do is we can also increase the speed of the ball. We can have power-ups. Like, so those are implementations we can add to it, like add power-ups to it, whereby you increase the speed of the ball and you can get power-ups maybe after playing for depending on how fast you play or something, if you can take out 10 balls within 5 seconds, those are things you can add, just to make the game more interesting and fun. So you can add that to the game, add power ups to it so that the ball moves faster, or the ball becomes bigger. And how do you increase the ball size? By just changing it. So we can't use a constant for the ball size anymore. That means we won't be able to use a constant if we want to do that kind of implementation. So we can define that since we can't scale it by using the scale, we can't do that. But we can change this dimension, the radius of the ball temporarily. We can do that. So those are implementations we can do. We can add fire. We can add more. Power ups. Basically, we can increase its paddle size. We can reduce the paddle size if you get a negative power up. If you get a positive power up, it works. If you get a negative power up, you understand what happens. So let's see what should happen here. So when the game ends, maybe successfully. So this 47, we have just about 10 more to go. 9 more to go. Okay, took out 3 at once. No, I hate working with the edges. Takes a while to implement. But just doing nothing can help you get it actually. See, like I said, get it. The last one. Oh, I didn't get it. Okay, so I'm just going to stay to see if you get this last one. Yes, done. So you can see you win, press out to restart, but this is terrible, right? Because the game still continues playing. We don't want the game to continue playing. We want it to stop literally. We want the ball to stop moving. We want the paddles to stop moving. You are done. You are done. That's the only thing you should do. Pressing R should restart the game, which works. But there's a problem because it just works, but we don't like the way it's working because now the text still remains. So these are the problems of AI that we can see clearly. So there are two things we wanted to revisit, right? So two things that does not work as intended. One, so we are going to ask it to just make these changes. When I complete the game, it displays the restart game text, right? But it doesn't stop the game loop. It should do that. That's the first thing. The second thing is that when I restart the game, it doesn't remove or despawn the text, the restart text from the screen, from the game screen. So first things first, let's look at where it added the restart. Let's look at restart. Yes, this is it. So what he did first of all is he checked for game win. He created a function called check for game win. He created that function. And what that function does is just to spawn a text, right? Spawn a text, which is why you need to despawn the text if the game is completed. So we just need to do that. And then there's undo restart. Undo restart is another function they created so that we can check and be sure that the restart is working. So he created an event, like I said, you need to create that. So he triggers that event whenever we do that. So the game trigger event is used in two places. In the undo game restart, and it's defined here. So undo game restart runs as an observer that checks if the game is complete. Remember, we know observer are things that you can use as event, right? So check if something has changed within the system. Update is something that runs once per frame. How do you make changes? Informed changes. You need the observers. That is what we use to handle the play collision. That's what we use to handle if the brick has been collided with, which despawns the brick. Remember, we despawn the brick by doing what? This observer is triggered when the brick is despawned. The brick comes already updated in check for collision. So we are not currently using this brick despawned, but we can use it for something else that we want to. So currently we tell the AI to make these two changes. When I complete, it doesn't do that. So it first despawn the text when the game is complete, right? Because now there's an event to listen to based on what we've done. There's an event to listen to. So we have the undo game restart. So it reruns the setup basically, which is what we've done. So we are saying undo restart, run the setup to restart the game, but everything works except for one thing. It doesn't trigger, it doesn't or despawn the the game information, the game check for game UI that it spawned earlier. So we need that to work successfully. So I would say how would you implement this? So we have to check. We want it to implement or re-implement this. So this is what we want to do. So if we ask it to implement this, it needs to do the check. It needs to modify it. It needs to remove what is not necessary and add what is necessary to it. So that's it. So the first thing to do is add break count resource to track total break count. Add break despawn event to trigger game state checks. So it needs to do some things and it needs us to make informed changes. So I said it's asking questions. Okay, that was the previous one. So modify check for game win to only spawn UI when game one is false. Exactly. So the check for game win, which is this place, like I said, it needs to check within this place. So in this case, it's not just checking for if the break is 0 before spawning the text, right? It's checking for if the break is 0 and the game state is not started. Those are the two things you need to check for. So we'll see how it's going to implement that. So modify the undo restart to reset game one resource to false when restarting, blah, blah, blah. Everything should be fine. Oh, started implementing already. It didn't even wait for me to suggest if it's right or wrong. But it seems right so far. So we can tell it to just continue implement that and see what the result is. So everything so far seems to be valid. So let's run this to see what do we get. All right, so let's see. Let's see if it has updated that. So first thing we need to check is undo restart. Did they add anything to it? Nope. But where it undo the restart, did they add anything? Yes, added a lot of things. The first thing is it despawn all the game entities first, which is reasonable. We do not want it to spawn any other thing. Once the game restarts, despawn the entire thing that you was implemented. The uwin UI, the bulk query, the paddle query, the brick query, the was query. Why? Because we want all of them to be respawned, right? So we despawn them, and then when this game is restarted, you are setting up everything again, which is the best way it should be done, right? So this is a way if you can also learn how to make certain things work, because you can't learn everything at once, but you can use AI to help you check. Once you know that, okay, this is how to write this. If you write something that does not make sense for you, you can say, okay, this will work, or no, I don't like this implementation. I believe this will not work, but you can guide it. So in this case, it's just despawning the entire thing, despawning the word query, every single thing. So I'm going to, okay, in order not to allow this or playing the game from beginning, they should be able to speed this up. I'm going to restart this, right? I want to speed it up. I'm going to go to game pause speed. So I'm going to increase the pause speed from 400 to 800. I want to double the speed, so I want it to run faster, so it doesn't take time hitting all of the balls and moving. I want to implement. So this is this is a way we can implement the power up I said earlier. We can implement a power up system so that when you get a ball speed power up, right, you already know that the ball gets faster like this. I've played countless games like this that happens. The ball gets faster, way faster, and then it just so this way I'm just going to leave it to do its thing and just move. We can implement it to be more faster by just changing one value. We can see the ball gets faster automatically. The collision still work, velocity still work, everything still works basically. So you can do that. Also another thing to realize is that game development is more about physics. It's more physics and mathematics combined. So it gets you to wonder if for a simple implementation as this, we already have collision detection and stuff. How all these complex games of maybe like car racing games, like like Need for Speed, all those kind of games. What kind of physics do they render for their games, for the motions, for the models, right, to be able to work perfectly for collision with other cars, for the all those wrecks that you see. So it's not actually just like this that we implemented it, but then collision states are also like checked. But in those cases, they have models that represent different states. So when you need to check for collision also. Now, when I collide with this, what happens? Right? Done. Okay, so let's see. Does it work well? Perfectly. It works perfectly well. So, but two things, we have multiple cameras. You can see the error on the screen here. So that means something is too wrong. You can see, say, ambiguity should be resolved. Multiple cameras respond accidentally. So that's the problem. That means there are multiple cameras. So to keep running that, we don't want that to happen. We definitely don't want multiple cameras to happen. So I'll just pick this error and drop it for it. You should understand once it sees the error. So I'll say, I'll just drop this. It's a warning, yeah, but it's going to keep taking the system resource, which is not what we want. So I get this from the build logs. I run the changes made fixed all the pending issues. Well done. But I get this from the logs when I run the game. So I'm going to drop the logs here. So this is how you can query your AI to get stuff done faster. Like I said, I'm using a free AI. Imagine if I'm using a paid one, how fast I'm going to be. But these are the benefits of AI nowadays. You can do very, very subtle, fast things because, yes, they exist. So exactly. So what we need to do, we can actually do this as to implement. What we need to do is the way, right. Let's see for where it did at this point. The way it despawned the other entities. I'm not going to do it because it has started. I don't want to tamper with what is working on. Like I said yesterday, when it's working, allow it to do its thing so it doesn't mess up your code. So we just despawn the camera. We could have done that here. We just say command or entity. Um, the entity now is going to be the camera itself, right? So just the same way we did UI, viewing UI here, we need to get the game camera also. So we get the game camera. Okay, it's already working on that. So let me show you guys from here. Now you can see this. It's adding a state, right? A struct, a component to the camera so that it can modify the camera itself. So you can see here, let me show you guys that same place again. Yeah, this is it. So you can see the camera entity is now despawned. So if you run the game now, everything should be as it was. So there should be no warning like that anymore. So I'll just tell you to run this. Obviously, everything should work well because that's exactly what should be done. That's exactly what I would have done. So that means you did the right thing. So, but interestingly enough, they actually understand how Bevy works because this is basically how this is what should have happened. So I'm just going to let it do its thing again with speed, run completely. So on the side note, one way to change the direction when you're playing breakout is to actually let the paddle go below, the ball go below your paddle. That way you can control the direction easily. So just a side note, like I know just a game cheats. Yeah. Or you can hit it with the side of the paddle like I just did, but then you need to time that. So I missed that. Okay. I think I've gotten the middle ones. Okay, so the last two to test our implementation to know if it works or not. Get it. Come on. Done. So let's check if it works. Let's notice the logs here. Let's see if it works fine. So there's no issue. So that means everything works perfectly well. So you can see how AI can help us speed up everything, and that means it works. So we can implement a level tracking system. Like I said, we're going to keep increasing it, increasing the difficulty, increasing difficulty until we get something extremely bulky than this. So the next thing we're going to do is I'm going to say, okay, now, yeah, this works. Next, I want to implement a level system and a menu that will be displayed, which means I can pause. Okay, let's start with the menu first. I want to implement a menu UI that will be displayed, which means I can pause the game and the menu will be displayed when I pause the game. Using maybe the escape key. The menu displayed should be displayed on the game UI and not on game UI. Probably on a transparent background, if that's possible. Ensure that the game is actually paused. The game loop is actually paused when I press the escape key or when I am not in the game screen focus. So we want to implement a focus system so that when we are not in the game screen, it should not be playing in the background. So let's do that. The reason is because you want to be the one controlling the game. You don't want it to be working like this. So it works, right? Everything we've done so far, the restart, everything works so far. So let's see if AI can actually implement this. Right. I don't want it to you don't want it to jump to code directly itself. So I'll probably stop it when it's about to jump to code. But let's see if it can implement this. But it seems to understand what to do. It's creating a game state of playing and post. A post toggle, okay, a node of the text for the menu and defining the systems. Okay, this seems cool. So I think this is fine. This is valid. You should be able to implement it. If I really understand Bevy, I'm surprised it's understand Bevy this much. Like almost 100%. It understands what to do. It knows where to implement, what to add. It probably understand the ECS system a lot better than I was expecting it to, because I've not needed to make any change today, which is good. So it's good news. That means you can literally build anything with Bevy now from scratch. All you need to do is just say, okay, I want to implement this. Can you help? But make sure in that case you have a VCS setup. In this case, I don't have VCS setup. I'm not tracking anything I'm doing, so I can't even implement checkpoints. So, like I said yesterday in the part 5 of the series, always ensure when you use AI, you have VCS implemented, you have checkpoints implemented so that your code doesn't go bad more than what you've created. Like I'm speaking from experience, I know what AI has done to your code base and my code base before. So, yeah, take it as an advice, guys. So, that is basically it. Well, everything we are doing after now is just showing you guys what can be done, possibilities, or what you can do. Right? We've covered most of what I intend us to do. We've built, if I'm not mistaken, 2 different games now. Yeah. I'm not saying we built it from scratch. Definitely not. This we don't nobody builds from scratch these days, except you are building something extremely different. But you need to understand what you're doing. So in this case, I believe you've learned how to build one. And based on the changes we are making now, imagine possibility of what you can create, right? As using Rust and using Bevy. So this is the way you can learn it, and you can create all of this and then go back to see what was implemented, understand the structure of the code. Use it to improve your knowledge on how Bevy works and how Rust basically works, because now you can click and click and click and see, oh, okay, I understand this. Why is there mutation happening here? Why is this reading this? Why are we using pointers here? Why are we using calling by reference? Why are we not basically, because Bevy has already handled all the lifetimes and all the traits and all of those things for you. You don't need to implement them. But that doesn't still mean you can't understand all these implementations. Understand struct perfectly well, because the majority of what you'll be doing with Rust has to do with struct. You can see that all that Bevy implements here is just basically struct. Even the component system is majorly struct. So it's a good way to look at it, even though it's a trait, right? But it allows you to So it has implemented a lot of things for you that you just call your struct on, define the trait on it, and that's all. You can use them within your code base simply. So this is exactly how this can be implemented. This is how we can, you know, we can implement a game here. Implement it from a very simple implementation to a more complex one by adding more features per time. Don't overload the AI with everything at once. Take it one step at a time. The way I did it now, implement a restart. He did it. He made mistake. Let's fix that. We fixed it. Now we're adding more things to it. Okay, let's update. Let's implement a menu system. Once we are done with the menu system, we will tell you to implement a level system. To implement a level system, then we'll continue from there. We can add more things to it. We can add different levels. We can tell you to add different steps. We can tell you to add power ups that drops periodically. So when we get this power up, um, the size of the paddle will increase, or the the size of the paddle can increase, or we can also add things like the size of the ball increasing, or the speed of the ball increasing, or the ability to take out multiple, not just take out one ball. Maybe we implement fireball so that when you get the fireball um, power up, right? We can just go through. We don't need to. We cannot be stopped by one anymore. We don't just collide with the brick, we pass through it. When it's any brick on our path to clear it, we can only be stopped by the wall, not the bricks anymore. Those are power ups. And now we can implement it. Why? Because we know that we have a brick system, we have a brick collision detection, we have a wall collision detection, we have all of those things. So we can remove that wall and brick collision um so we can just make it conditional so that whenever we collect the power up, which is at the fireball power up, the brick collision is literally conditioned. It's determined by that. So these are things we can do, and it's fun to be able to even talk about this because it is possible, right? It's extremely possible. So yes, I believe we've learned a lot from this. I believe we've learned like multiple things from this. So yes, I just want to complete this so that we can have an idea of what we've done today and then know how to fix that going forward. So this is just me trying to just play around with what we've done and to see what is possible for you to create, because you cannot limit yourself with what it is that we have. For the examples now, you can always go ahead and create more stuff, and you have all the resources. I'm not using something hidden. You have everything online. You can pick it, you can test it out, you can try it out yourself, you can see the resources, you can see everything that's been implemented. So yeah, so this is basically what we are trying to do. And let's see, for entity in this command.word.get. No, I can't use command.word. We need, okay, I'll leave it to. No, the spawn children exists. What do you mean doesn't exist? If you're using the spawn, you need to consider the children. The spawn children exist very well, perfectly well. No, 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 no. So we are trying to get this. Um, but the command doesn't have the word. Why are you using the word? So I'm going to add this. Okay, so once this is done, let's just wait till this is done, and once this is done, show you guys what has been implemented. You can literally see the amount of time it has saved us. We don't need to write all of this, because if I would write it, I need to write all the menu integration, camera query. Okay, not for this, not for this. This is for the pause. Or when we pause it, actually, okay, yeah, for this, because when we pause it, we need all of this: the resume button, the restart button, implement all of them, copy them, be sure everything is in the right place. But with AI, we can just check the interaction and make it tell it to make changes, and the changes we can track just the way I'm tracking it right now, seeing everything it's doing. This doesn't go here, remove this, changes, make some subtle changes that makes it faster. So instead of rewriting everything, I'm making changes, which means I don't need to write anything at this point. I'm simply just making changes on what we are working with. So of using AI and the power that you get from using AI to implement your code. So let me remove this here. I'll remove this here. So if I'm not mistaken, there are no more errors. So let's try to restart and see if it works fine. Does it break? Does it work? Okay, it seems like it will work. No error so far. Quite impressed. Wow. Okay. Impressed. Very much impressed. This is what we get. So we've implemented all of this. This is impressive, right? Yep. So let's do this. We have the resume function. You can see it works. Let's restart and see. Restart works. Let's quit. And it works. Perfectly work. So everything works as we want. And that, and we can see the way the background was implemented, right? We created that form of transparent background from us. Now, this is significantly different from what we did yesterday, whereby we had like different screens. So what was done today is more like using the node with children implementation, like we've always done with text and all that thing. So let me show you where that was done. Let me look for it here. I'm sure you did that somewhere. Yeah, with children, you can see this. So with children, you can see this with children that when you press this, what's the text here? The title is what? Post. You can see. So this is where it was implemented. Spawn post menu. So the first thing they did was to define the position type, the width, the height, the alignment, and he added some other things to it. But he added border radius to this to make it a bit better. Because the first thing he did was just to spawn the entire thing and background color. But after spawning the background color, we added this max to it. But we don't want it to be max. We want it to have like a default value, right? So what we can do in this case is we can define the radius ourselves without using the full radius. So we can say all the radius without using max. So we just define the position. In this case, it's going to be like in position, let's say 10. Well, let me say 10.0. Right, if I'm not mistaken, it's expecting what a value of, of pixel 10. Let's make it okay. Let's make it 12. I prefer to make it an even number, really, like that is divisible by 4. So let's do this and let's respond this and see. So we are doing a bit of more UI. Now imagine how long it would have taken us to write all of this, but because we use AI to do it, we implemented 3 other features as much as we can, as fast as we can. So I'm going to make changes to the UI. If I press this, this side looks nice. So it looks a bit better, right? And even if I go back to the game and I play the game and I go out of the game, it should pause. Okay, so this has not been done. But I want that to work also. So I'm going to definitely improve this game, improve it by making it do other things. Now, this is fun actually. So I can find this fun, just like the one we did yesterday, whereby you can blow up the game. So I can do it in this way now. We can actually add these two games together. We can implement them in. Now, if I press pause, you can see it give us this background, and we can still see the background, but then it's overed on it, and we have all of this, and we have the resume, the restart, perfectly defined, very good UI implemented. We can quit, we can resume, we can restart, all done perfectly, right? Um, so you can see this working, like coming alive, every single one of it, the components, the entities, the system, the observers, the text, the buttons, the brakes, the collision detection, all of these things are working together. And we can see them all coming alive here, right? Literally giving us this very beautiful view that we can see, right? And you can see this, it works perfectly well. So we're going to resume the game. Let's just complete this. So I think I like the adjustments done to this. I'll just tell you to make more UI adjustments to the game. Yeah, I win. Press out to restart, and then I restart. But I don't want to restart this. So what I want to do is add more functionalities to it. So we've done all of these things. We've added everything we want to. Now we can do one more thing. We can do okay, it works fine. So I want to implement one more feature. So the feature we want to implement is, what was the thing we mentioned the other time? Did you say levels? Yeah, I wanted to implement levels. But first of all, let's do this. So I want to improve the UI of the breaks, the game, the ball, and the paddle. It should look much of the gameplay. The pause menu looks beautiful. Let's improve the UI of the gameplay as well. It should be so one. Let's allow it to implement this. Let's just watch what it does. Now basically what you do now is just you walk, you watch, and let's see. But the beautiful thing here is because we now understand how Bevy works and how Bevy handles implementation of all of these things. It becomes easy for us. We don't need to stress about, oh, does it implement this way? I don't even know what is happening here. But now you understand what is happening because you can literally say, okay, yeah, this makes a lot more sense. Let's do this. No, this doesn't work for us. Why not do it this way? Or the same way we make changes. You've seen us do make two changes right now, right? Make two changes. So in this case, it wants to implement different colored bricks. Each row should have its different colors. Um, okay, so we want to implement the scoreboard. It wants to enhance that. Yeah, exactly. Rounded paddle on the ball, slightly lighter, more modern wall colors, maybe a subtle glow on the ball. Perfectly what I want. Replace the gray gradient with a subtle gradient or pattern, darker theme for contrast. Okay. Yeah, implement of the UI. I really like the style is going with. I like the enhancement. I really wanted the enhancement to function with no. Okay, so I want the enhancement to start with the paddle, so which it already handled. It says it's going to make it rounded and increase probably add a glow to the ball, which I want also. And it also wants to add other things like the when you complete the game, the you win message should be a bit better, right? Currently, it just looks bland by just adding a green text that says you win, press out to restart. But it should be better. It knows it should be better. So let's just leave it to implement all of this and wait. Probably do all of this in 3 minutes, literally in 3 minutes. Something that would have taken us hours to implement. So we're in a good spot with AI when working with things like this, but you need to be careful because Like I said, you are the one guiding what it should do. You need to allow it to do what it wants to do, but you need to guide it and say, do it this way, do it this way, do it this way. If you want to get the best out of it. But you need to understand what it's trying to do first of all. It literally makes sense that way. So the beautiful thing about this is Rust is strongly typed. So if there's any error, no matter what, you already know. Without even the AI can automatically know by running the check and knows that okay, this is wrongly implemented. It's not like a language where you won't see the error until runtime, right? Yeah, very much at build time, you already know the error. So while you are already checking, while you are building the error, you program, you already know, okay, there's a problem here. So Rust gives you that privilege and it helps a lot with AI too. It's one of those things that AI you can appreciate when you're working with artificial intelligence to make sure that, oh, this will surely not run if there's an error. So you can keep fixing it, knowing fully well that okay, if it runs, there can only be a crash in logic, not in the actual build of the game. So that's something to note there too. Okay, so there seem to be a lot of errors. I think it's just these are things we can always fix. Let it just undo the main thing. Oh, it's back with this section 0. I literally don't like using sections. Yes, section doesn't work. Like I don't understand how it doesn't understand that section does not exist. And you keep making it look as if it works. It doesn't work. You can't change the value. You can't change it like this. I need you to understand how it changes it. Convert it by removing this. There's no font weight here anywhere. There's no background color. Why are you making such mistakes? There's no background color anywhere. Bevy doesn't use font weight and background color. Transform should work here. Why is it complaining? Wow. Oh, no, 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 no. We can't transform here. Why is it doing this? Same applies to background. Why not use something like this? You literally did this here and then you did nonsense here. Jeez. Let me just copy this. Now, this is what I'm saying, right? You already know what you need to do here. If you come across an error like this, you know it doesn't understand what to do. So just help it. So I think that's the only thing we need to beat with more. Aside from this is just because we don't scoreboard. This is how to implement this core. You literally need to update the scoreboard. Scoreboard UI. Okay, so I'm trying to look for where it was actually used, how it was written initially, not this nonsense that this guy wrote for us. Literally using sections like, no, don't do it that way. Yeah, this cupboard like this. So this is how to update the text. I do not understand why he's writing the text that way. This is how to update the text. Update this cupboard by just changing this. Looking at the example itself, you can see the way you updated cupboard here. If you scroll down, you see the update cupboard close to the bottom here. Oh no, yeah, this is it. So this is simply I use the update cupboard, and that's just call dot to string. Nothing else, no text, no the value like we have here, just unnecessarily written. We do not need all of this. Just update the text as we have. This is wrong. Okay, so let's see what happens now. We are writing as much as we need to. We are trying to just implement this as best as we can, to the best of our abilities now. So let's see what we get. So the implementation was very much wrong before. We should be using the text UI component, which you already have defined, but for some reason, it's going with this minimal previous way of implementing it. So this all boils down to the code, to the data that the LLM has, which I believe is old data of Bevy. But a lot of things have changed over time. This is like way old and not even expected at this point. There's a lot of things being done. So I understand this could be used, but not in this case. So yeah. Okay, so it's completely said it fixed it, which I believe it does fix it because now it's using the right handle text method, which is perfect. So one more thing is the font weight. I don't think there's anything that to do with weight. Yeah, Bevy. So I probably just remove anything that's to do with weights for text weights in this code. We really don't need it. Now let's check if everything works. I believe it should work because from what I've seen so far, this is perfect. I saw an apply fix just now. Okay, let's see. This should work. Nope, it didn't work. So we get this error and encounter the panic. Oh wow. Okay. So everything ran successfully until we got to this point. So what I'm going to do is just give the error, give the message to you to allow you fix it. Okay, so once we can close this, then we'll just close this for today. We simply have done a lot. Um, well, I just want to show us these practical ways and the practical things you can do, the options, the way you can use AI to implement a lot more functionality. It helps you to understand what to do because now you can make modification, make edits, suggest new things like we've been doing now, suggest how it should implement it. Thank God you have a very vast library of examples. You can look at what's works similar to what you have and give it an example of what to do. It knows where to check and what to change. Right. So um I believe this is perfect. But then let's try completing this to see. No, 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 no. Don't use text with sections. Don't use text with sections. Okay, the first thing I need to do, I'm going to copy this. So I'm going to give it to client. There are two different models, so let's see if one can fix it and the other cannot. So it's actually perfectly correct. Yeah, it's suggesting the same change. So the same change should be textpan.default. We don't need that. Okay, so fingers crossed this should work. So we can call this a day before we implement the last thing, which will be on part 7. So part 7 is just going to be like bringing many things together or even continuing with this to kind of like expand it and bring together everything we've done so far. So this is how we can use AI to speed up your workflow. Currently we have, okay, I already cancelled that. So I will show you guys what we have now once this is fixed. Okay, so I think this seems to know what to do. Yeah, proceed. Because we need to use the children property, not what that one was suggesting the other time. So we need to use something like this, not something like this. So this, okay. So let's see. I don't want you to use the section. The section will not work. It's trying to use the same thing, but that will fail. So So let's see if this can fix it for us. Now this is dangerous because we are working with something that doesn't really have any um should I say any way to restore checkpoints or to go back to a previous time, previous point in time or version history or whatever. We have none of those things implemented. We've not even added any of it to it. But we're trying to make changes to a code base that is almost 1,000 lines of code at this point, 994 lines. And this is a problem for AI at many fronts. So this is just to give you a way or just to show you that yeah, these are the issues we encounter. But then you can't shy away from using AI because I know every one of us here we definitely use it and do use AI for one thing or the other. So we this is just plain wrong. What is it doing? What are people doing? Okay, so if it doesn't get this, I just have to revert it to what works and then we take a very simpler approach because I, I don't I do not understand what is happening right now. So what I'm going to do is to like reset the entire thing. I'll restore it back. So let's see if you can get it. If it doesn't get it after this, I'm going to cancel this, take it back to the previous one. Then we take it one by one to like fix the text, right? This do hallucinate a lot. I get this hallucination a lot from this model, so I understand it's still not going to fix it. Yeah. Didn't even fix it. Get out. So I'm going to restore everything that it has done. Like it is literally so wrong. Restore file on task. So everything should be restored to the previous one. And then I'm also going to restore this one because it literally has done what we do not want. It literally removed a lot of things which we don't want it to do. And so I'm going to remove that and tell it to restore file and task. So confirm that restore everything to the way it was before. So if you do this, you can see we don't have the error anymore, but we still have a build error we need to resolve. So everything it was implementing just now should be done in Node like this, but it kept writing it as text entities, which is wrong. This is how we should be writing it, but for some reason it doesn't understand what it needs to do. So let's see. If I rebuild this, I'll still get the same error, right? But I'm trying to show something else. Okay, so let's see if this can be done. Last one. Now, if this is not resolved, then I'll try to resolving things, but I won't just keep you guys on the call. So I'll proceed to resolve this after the call. I think we've done 3 hours, almost 3 hours now. Yeah. Let me check this update scoreboard. So the first thing is, so we are using the same thing. We are using this core, we are using the mute writer for the entity, and we are changing it to score onto high score. So that means we are keeping track of high score. Oh yeah, implemented high score. So we asked the AI to implement some some enhancements. So we added the high score so that we can track the high score. But the question is, what is the high score in this case? Like literally going to be the same for every value. But yeah, okay, let's see if he implemented something that makes it dynamic. I didn't check. I just told you to implement enhancements, which you can always modify. So this is just in case you want to have something, an idea of what to implement. It gives you very good ideas, most times the wrong way, but still gives you ideas. So the first thing we need to do is change from text new. So let me look for text new this, which is font size from here to from section, which is definitely just I really don't think that's going to work. There's no from section here at all. So yeah, first things first. Notice that Bevy text does not have a from section function implemented on it. So we cannot use the text from section function like you suggested. Suggest something else that aligns with every new latest version. So this is me saying that it's wrong, which is expected. You should be able to tell, yeah, it is wrong because literally wrong. We can't do that for this because we are implementing this as a child node, right? It's a text node, which we defined as new, and we define different properties. But it's telling us to use from section, which does not even exist on the new, and then write it this way, which is going to fail drastically. Of course, we can use this because I don't even see the need. Okay, this one rather. We have this. We don't have the font width. Font width doesn't even exist on it, so we can't use that. We cannot use it from section this way. Best thing we can do, we already have the score value, right? Best thing we can do is implement that, but not add the value to it. Let's see if there's any changes to suggest. Yeah, uses test new with children containing test span to create sections. Score volume is score setup is this. High score is this. Update function is this. Let's see if this makes sense. So the score column, like it's suggested, which is this one, creates a span of 14, text font color. Now you're talking. Now this makes a lot more sense. Why? Because we need to create a node, just the way we did here before, for this score, so that we can add the same thing like the scoreboard and all of it to see if it works. So I'm expecting this to even make a lot more sense than what it implemented before. So let's take this approach and use it. Right. I believe this should be better. I'm not fully convinced, but looking at the syntax, it makes a lot more sense. So I believe I can still work with this and accept this as a requirement or as an update that makes a lot of sense. So I'll tell you to make these changes. The previous one is definitely wrong. Like there's no from section anywhere. We already know that. We've established that since the part 5 of this series, but AI is AI and AI is dumb. That's the way I always put it. AI is just computer too. It's garbage in, garbage out at the end of the day, but it's smarter way to garbage in and garbage out. That's basically what AI is at this point. But yeah, it makes life easy for us, so we appreciate it. So yes, okay, there's still one more error. I think I saw it. It's using text the default. It can be used for. Okay, it can be used, but not in. Okay. Let's see. Text default for the child. Okay, so we define the high score, then we define the text for the child default font. This. Then the update function remains the same. Nothing changes. Let's see the update so far. And it's added font weight again. Font weight doesn't literally exist, like at all. Doesn't even exist at all. Text font, text color, yes, we have all of those things, not the weight. Okay, fingers crossed. If this works, then we are done for the day. Let's see. Let's hope it works fine. I think I trust this implementation way better, but I don't know. I haven't gone through the entire thing. Don't crash, please. Oh, finally. Okay, so this is what we converted our breakout code to. He said he was supposed to add. Now you can see the problem here. You can see what this created here. You can see the problem is that it added two text on top of each other, and there's like an overlay of two text on each other. You can see. Okay, I think I understand why. So we can fix that. What we can do is let's look for the I score. First of all, we look for the I score. Where did we define the I score? We change the position. Once you change the position, it should display well. But currently, I think everything works well. 37, 37. So it's displaying the I score and the other score together in the same place. So let's look for I score. Okay, so this is I. Yes, this is I. So define the position. Position is not defined. Okay, so I'm not going to copy it. I'm not going to write this. We already have position defined somewhere. Yeah, this is this. So I need this. Oh no, I need better one than this. Okay, you know what? I'll just stick to it. Position type, position absolute. Let's say bottom. Yep. Nope, 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 nope. Left. Yeah. So let's do this. Let's run this again. So, like I said, this makes more sense now. So we successfully implemented. So by just correcting the AI to do what is right, we've been able to implement almost 1,000 lines of code from barely 500 lines of code. I think now we've crossed the 1,000. Oh, 953. So you can see the fix we did. So it's not perfect yet. We need to drop it a bit more. We need to change it from this to like 40, let's say 30, and change this to 0. We don't want it to, we want it to be far left. So just display below the original one. So that's our intention. So now we have a better scoreboard because we're using a scoreboard now so that we can query it. And now you can see. Now we have colors for it and a form of gradiented, but annoyingly there is still no radius defined on my paddle. I want my paddle to have radius. Like radius is defined somewhere. Yeah, like literally it is defined on this. There's a border radius on the child itself, which spawns the screen, right? So if you can define border radius for the screen, it shouldn't be a problem for the paddle. Let's look for the paddle in this case. This is a lot of query for the paddle. Let's go here. Okay, let's go to the setup where we spawn the entire thing. Let's see if we can transform it from there. This is the paddle color. So we can add the border radius. Perfect. Like it shouldn't be a problem. So let's run this. But this is going to be a lot padded. It's going to be more like a rounded edge now, which we don't want. But I still prefer sticking with that. It's just for aesthetics. I know it's not okay. Didn't even apply it as I wanted. This is a paddle. Yes. This is sprite. Paddle sprite. This is a transformation. Then why doesn't it apply the border radius? Okay, I'll just assume that there's something wrong with that. That will fix eventually, maybe later on. So let's test all the features we added. We added the escape, it shows this. We added the resume, it works. We added the resume, it works. And we added the quit, and it works. So let's complete this, and we change the UI a bit from the original thing we had, which was this this way to know something like this with a better scoreboard, a high score with different colors for each row or each column rather, and the paddle. Okay, the ball has changed. The color of the ball changed. So I don't understand the high score system yet because we don't really have anything to change. But that's the high score only comes maybe if you are tracking the time it takes to complete it, but not the balls itself. And now we have a better complete score. And you can see you win. Your final score is 56. So now these are all the implementations we've done. These are all the things we've been able to get started with and also complete successfully. So this is how collation works, right? Based on the definition of the let me see the diagram. I think the diagram is a bit simple, right? But this captures all you need to know about how bounding circle and bounding rectangle works. So if you understand this and the mathematics behind it, you can literally implement your logic to implement collisions, right? So yes, that should be all for today's episode, part 6 of Build a Game in Rust using Bevy series. And hope you guys have learned something here, right? From the part 1 to the part 7, okay, part 6. We're going to take the last part tomorrow so that we can round up with the series. I plan that we'll do a week. So we started part 1 on Sunday last week, and then we'll be ending it tomorrow, just in 24 hours time, barely less than 24 hours to implement the last part. So we can see if we started this, we can press the arrow to restart and it works. So literally this is what we've implemented and I believe you guys have learned something from this. So if you have, please remember to drop your likes, your comments, and if you don't want to miss tomorrow's the final one for this Bevy series, then I urge you to subscribe and get notified so that you can get notified before it begins. And then you can follow along for the completion of what we will implement in in the next episode of this series. So thank you so much guys for joining. Thank you for being a part of this journey from the beginning and see you guys in the next one. Bye for now.